So Python is one of those languages that is very popular for many reasons. One of the main reasons is that with Python, you can use Python to do many things, to build applications that are very powerful, from web apps to embedded systems to creating desktop applications, in scripts that facilitate and automate your life. So Python is very popular for many reasons. And also by mastering Python, you are opening up a lot of doors, especially when it comes to AI, as well as data science, machine learning, and so many other industries. So needless to say, Python is the language that you must master. Doesn't matter if you know Java, you know many other languages there, but Python has to be one of those that you need to understand. You need to learn how to use it. And so that's why I decided to create this mini course for you. That way you can go from zero to hero with Python, to learn the basics of Python, how Python works, variables and function, classes, branching, and so many things. So without any further ado, enjoy the Python masterclass. So what is Python? Now, you may have heard of Python many times and you never really had a chance to look into it. Python is a beautiful, amazing language. So Python is a very powerful, popular, and versatile programming language. And the reason why it's popular is because of its easy syntax. It's also easy to learn than other languages, as well as it's used in many different industries. Now, here are some of industries where Python is used predominantly. So we have web and internet development. So Python has a lot of different frameworks. So a framework essentially is a set of tools that allow us, facilitates developer to build software. So Python has a lot of different frameworks. One of the most favorite, and the one that we will be seeing in this course, is the Python framework called Django. Okay. And there's also another one called Flask that are widely used for developing websites and internet applications. And the cool thing is many companies, famous companies, actually use Python and these frameworks to develop their massive applications. Python is also used in data science and analytics. So Python's data manipulation and analysis libraries, because it has a lot of those, and also visualization tools make it a preferred language for data scientists. Okay? So it's used in industries ranging from finance to pharmaceuticals for data analysis, predictive modeling, and statistical research, and so many others. Also used in scientific and numeric computing. So this includes physics, astronomy, biology, thanks to many libraries that Python comes with. AI, artificial intelligence, okay, so machine learning, and there's so many libraries that are around AI and artificial intelligence, which are Python based. Because of its readability and efficiency, Python make it a good choice for building desktop GUI applications, game development, and network servers. Also used in education because of its simplicity, makes it even more popular language for teaching programming. So both in introductory courses and in more advanced studies. So Python is also used in quantitative finance to build trading algorithms, perform financial analysis, and develop risk management systems. So as you can see, there are a lot of places where Python shines, where Python is used, mainly because of how versatile, how easy to learn, how easy to pick up, how powerful the language really is. That's why it has a range of variety of places where it's used. Python is often known as an interpreted language. Now, we're not going to go into too many details about the internals of Python, but it's worth to distinguish, it's worth to understand why is it called interpreted language and sometimes compiled language. So Python is both, is indeed a compiled language as well as interpreted language. But the thing here is that it's also considered an interpreted language. What is that really? What is this whole process? of compilation and being interpreted. What is all of this about? Let's look at the Python compilation process. So the idea is that we have the source code in a file called, for instance, app.py, which you will see. So py stands for Python. That is the extension that will tell the compiler, your system, that this is a Python script or a Python program. Okay, so that goes through a compiler. So a compiler is indeed a very complicated software that sits there, which will take this code, will compile it, make sure it's all good, make sure it doesn't have any errors, and then it's going to generate what we call a bytecode. So bytecode is a lower level platform independent representation, in this case, of your source code. Now this process happens in the background. You don't have to worry about all. You will see, just create the file, the app.py, and then run it, and then in the backend all that happens and we see results. So essentially what happens is as follows. So we have the app.py, goes through the compiler and transforms that into bytecode. Again, this is the lower level platform independent representation of your source code. And then what happens that then the next process happens, which is the interpretation process. The interpretation process, it takes the bytecode and then passes it through what we call the Python virtual machine. So essentially is another software that has all of the code, all of the system, all of the tooling to interpret this bytecode, to run essentially this bytecode. So essentially, once that is executed, the bytecode is executed, right, ran in this case, that's when we get results. In this case, we'll have something printed out that says hello world. So this is very simplistic, nothing out of this world. So that is why they call Python is both compiled and interpreted, but mostly you will hear that Python is indeed interpreted. Just a very light overview of what Python is and what is happening in the backend as we run our Python, even though we haven't done that. But I just wanted to give you an overview of the compilation as well as the interpretation process in Python. Okay, so let's go ahead and install Python on our machine, specifically on Windows. All you have to do is go to python.org like this, and then this is what you will see. Now there's a lot of things here, and what I will need to do is to go to downloads, and you can see as of recording this video, Python is 3.12.2. Now don't worry too much if you're watching this later and you see a different version here. All the things that we're going to be looking into in this course should work with different versions of Python. Okay, so focus more on the basics, fundamentals of Python. All right, so let's go ahead and say download. Click that, which will start the download process of Python, the executable folder or file that we can then install Python on a Windows machine. Okay, once it's downloaded, just double click to start the installation process. Okay, now there we go. This is what you should see, and make sure to add python.exe to path. This is very important because if you don't do that, then this is not going to work. And use privilege when installing. I like to use that as well. So go ahead and click install. And in this case, do you want to allow this app to make changes? I'm going to say yes, that's fine. And it's going to start installing Python. Now, this may take a little bit, so let's just wait until it's done. Okay, so it should be good now. Let's go ahead and close. And the next thing you need to do to make sure that Python was installed is to go find the command prompt. So what you can do, you can just search cmd like this, and you should be able to see command prompt. Click, and then this is what you will see. Now, let's see if Python was indeed installed. If you type in Python, hit enter, you can see that indeed Python was installed because we see here Python version and all of this great stuff. So now you are inside of a prompt. So essentially you are inside of a Python shell that is running where you can actually type things and things should happen, right? You type Python code. What I want you to type is something like this: print parentheses, and inside of parentheses just say hello world. Okay, and hit enter, and you should see hello world as such. So we are inside of this interpreter of Python that allows us to write Python code and see the results. Pretty cool. I can even say 2 plus 2, hit enter. You can see it looks at this expression. It says 2 plus 2, that's an expression, which means it yields a result and gives us that result there. Very good. So if you get to see this, that means Python is indeed installed on your machine and we should be ready to go. So Mac usually come with Python already installed, at least the older version. But it seems like the newer version, they don't come with Python installed. Either way, we need to install a newer version on Mac. So it's very simple. Just go to Google. And then let's go to python.org. And of course, this is what we see. And then we could go to downloads here. You can see because I'm on a Mac already, that is toggled. So I have Python 3.12. So go ahead and click this, and then you should go through the process of installing on your Mac. So I already have that installed, but it's pretty straightforward. Just follow the instructions and you should be good. So once you have Python installed, everything is set up on Mac. What you can do is just say Python 3. Now keep in mind on Mac, you usually want to say Python 3 and hit enter. And what will happen? This will happen. You should be able to see Python and the version number. Remember that the version could be different from when you're watching this video, but that's okay as long as you have it installed. And then we have this Python prompt here, which allows us to get into a Python environment shell where we can start writing code. That's why you see these 3 greater than signs there. So now here I can say something like this: print, parentheses, and quotes, say hello world, and close. So this is indeed a Python code. So if I hit enter, I should see this printed, hello world, right? I can even say 2 times 6. This is indeed an expression, which means it yields to a result. Python interpreter will go ahead and run that and should give us 12. So this tells us that indeed we have Python installed on our machine and we are ready to go. Next, we need to install a tool where we can edit our code. We have what we call an IDE. So IDE stands for Integrated Development Environment, and there are so many out there for Python. Okay, so for me, in this course, we're going to be using VS Code or Visual Studio Code, which is a very light integrated development environment that is very popular and it's easy to use. It's just an amazing thing if you've never used it. Okay, so that's what we're going to be using in this course, and I encourage you to do so. Let's go ahead and install Visual Studio Code. So if you go to Google and type in VS Code, this is what you see. So you can go to download. So if you're on Windows, go ahead and click here to download Windows 10, 11, and so forth. And if you're on Mac, just click on this one here. It's very simple, straightforward. Just download it and you should be good. If you are on Linux, then you have these flavors here. All right, so go ahead and download your version of VS Code and I'll see you next. All right, so once you have installed VS Code, you should see something similar to. Now remember that it may not look exactly the same because with VS Code, you can customize it, but that is besides the point here. Right? So what we want to focus on is that you have VS Code installed and you're ready to go. But before we move forward, there's one main thing that I want to point out. If you see here, you can see there's this icon called extensions. So I want you to click on that. So extensions are just pieces of code or pieces of software that you can attach as plugins onto VS Code so that it can enhance your development experience, right? So in this case here, I want to go ahead to find this Python, just write Python there. And I want for you to go and find this Python extension pack. So if you click on this, I already have that installed. I'm going to close this down. So what is this? Well, this is a pack, right, that contains all of the extensions, tools that will make your life way easier when it comes to Python. So go ahead and just install all of them. This one has 1, 2, 3, 4, 5, 6, and 7 extensions in one. So all of the extensions that are really important for Python development are in one. So go ahead and click install. You should see install here. I have disabled because I already have that. But for you, go ahead and install that and you should be good to go. Right? If there's anything else we'll need in this course, then I will introduce when we need that. But this Python extension pack is the most important one for you to have a pleasant time in VS Code learning Python. So install it and we should be good. So now that we have everything set up, let's go ahead and create a Python project real fast here. With your VS Code open, what you want to do, go up here and go to File and then say Open. Right? You can also say Command O to open, or I believe Control O on Windows. And this will prompt you to open a folder. So go to your desktop somewhere, and then I already have a folder, so we can create a new folder. I'm just going to go ahead and say Python code. That's where everything's going to be, but you can create your own folder and then open like this. So now you can see that we indeed have a Python code there. So this is our folder, and you can click and close, and then we have this outline, timeline, all these different things. But what we're interested in here is that we can go ahead and create a new file. So click here, create new file, and I'm going to call this app.py or py. Hit enter to actually create that file. Okay, so app.py. All right, so the great thing here is that you can also close the Explorer and open. Close and open, which is very nice because then you can have more space. And the great thing here to write a Python code, we are going to call, in this case, a function. So a function is just something that does something, right? So we're calling a function that was pre-built in Python to do something. The most famous, most popular one, we'll see, we'll be using it all the time. We've used it actually, is the print function. What it does, well, it prints whatever we're passing it, right? So I'm going to go ahead and say print like this, and then put that inside of parentheses. And then because I want to print a string, a message, I will put that inside of double quotes, or I can actually add that inside of single quotes. So for now, I'm going to put that in double quotes. And then I'm going to say hello there, right? Like that. Let's go ahead and save. You can say Command S or Control S on window to save that. Very good. And now how are we going to run this? Well, there's a simpler way to do so. Instead of going to open a command line or command prompt or terminal on Windows, we have a built-in terminal or command line in VS Code. That's the reason why this is an awesome IDE. I love it. So to open that, you say Control backtick like this. So I'm going to close and open again, Control backtick, and that opens indeed the terminal. And it's already inside of our directory, because if I say ls, for instance, you can see that it goes to the desktop and Python code. Now, just ignore all of these things here. I have something installed on my computer that just gives me these random things, but just focus on what's important here. All right, very good. I'm going to say clear or CLS on Windows. To run this file, I'm going to say Python 3 because I'm on Mac. For you, just say Python, right? So I'm going to say Python 3 and then the name of the app.py. So it has to be the name of this app.py, which is the file we want to run. Hit enter and you can see we have hello world. And we can do other things as well. I can say, for instance, print 3 times 5. Okay, this is indeed an expression, right? We want to print, so we should get a result. So because we have this first print hello there and we have another print, it should have hello there and then the result, which is going to be 15. So I'm going to go ahead and I could type again, or I could use the arrow key up to go back to the previous typed command, which is real cool, saves us time. So go like that and hit enter, and I should see hello there 15. Now, if I want to go ahead and close this, I go Control back tilde, and our terminal is closed. All of the things that we talked about, the compilation process and the interpretation process, it's happening in the back end, and we don't even have to look at that or worry about that. Okay, and we learn also how to open and close indeed our terminal here. Okay, so we've installed our VS Code. We've done a lot of things. We've also ran our first Hello World program in VS Code. Of course, we installed the Python extensions that we need, specifically the Python pack extension. And now what we're going to be doing is we're going to start looking at the basics of Python. So Python variables and simple data types, because these are the building blocks of any programming language. All right, let's go ahead and get started. Very basic concept in any programming language is the concept of variable. So in Python, we can declare variables by just naming them. So if I say, for instance, name and say equal and put that inside of double quotes, say Paulo as such. So this is a variable called name. So in memory, we're allocating a little space in memory where we're going to put, in this case, this Paulo here. So referencing this Paulo, which is being held in name. Right? So in memory, whenever we want to get Paulo, we will use name to reference that. Okay. So in this case here, if I go and say print and then pass the name, which is this variable here, we should see something. So if I go ahead and say Python 3 again, something like this, and app.py and run, we should see Paulo because we have the variable name, and then we say printing the name to say go to the memory and find this name reference in the memory, which is going to be referencing indeed the Paulo string. So this is indeed a string which is in double quotes, but we could also put that in single quotes. So it's the same thing in Python. Okay. So if I go save here, because I have something installed as an extension that will always change them to double quote. Now the thing to keep in mind, of course, is that when we reference the name variable here, when we're printing it, we need to be very careful, because if we were to do something like this, somehow just call nam like this and save and go back down here, arrow up and run again, we can see that we have this error here. Now this is important so that we know exactly what's happening, because things happen. You may type wrong a variable name and then things come down crashing. It's okay. So what this says here says name error. Name, nam, is not defined. Did you mean name? Okay. So what this is telling us is that it's going to give us trace back of what or where that happens. You can see it goes to our desktop where our folder is, then Python code, that's the folder, and then we have the app.py, and even gives us the line number, which is line 3. So as you can see, line 3, we have this issue here. And the beauty of VS Code is that it's also giving us this squiggly line to say something's not quite right, so you might want to take a look at it. Right? So this is important to always remember, that whenever there's an error, right, it should show us the line number and where the issue is. All right. And in this case, also, it gave us the idea to say, did you mean to say name instead of num, which indeed is true. Okay. So this is how you kind of debug your program to make sure you can find the errors and trace them down and fix them. And again, if you save this and go ahead and arrow up again to say Python 3 or Python app.py, and you should see Paulo. And of course, this we can add another one, say called message, for instance, and put a string here. Hello there, Paulo, as such. And I can, of course, reference that message again here, just say message as such. If I save that, do the same, go run, and you see hello there, Paulo, which is indeed this message here. And as you see, this first one, which is name, right, variable, which has Paulo, since we're not referencing it, we're not going to be able to see because we're not printing it out here. All right, so very simple. There we go. This is a variable. This is how we instantiate variable or declare variables in Python. Now in Python and many other languages, we have data types. So when you say name is equal to Paulo, we're creating a variable, as we said, and we're setting this variable to Paulo. So what is this Paulo? Paulo here is what we call a string. And we can tell that it's a string, first of all, in this case, because we have double quotes, or as I said before, we could have also had single quotes, but it's a string. So what is a string? Well, a string is a series of characters. So this would be a character, that would be a character, as well as that, and so forth. So when we put all the characters together, that's what we call a string. So a string is indeed a type. So how do we declare a string? Well, as you can see, I can go ahead and say again message here, and I can put in single quote, hello there, this is good, something like that. So this is indeed a string as well as that. Now, because everything is available in Python to us, that's the beauty of Python, because it simplifies all of the ceremony that comes when we want to use it, right? What I mean by that is that there are functions that we can call on our strings, right? So as you saw earlier, we said that when we say print, this is indeed a function, which means we can call it, which essentially means we can execute something. So we said that if I pass message here, what will happen is that the message which this variable is holding, this should show in our console. So this is what we call a function. And we'll look into functions into more details later. But if you hover over, you can see that you should see some sort of a documentation that tells you exactly what's happening. So this print function comes preloaded with Python. We don't have to do anything. It's just there ready for us to use. Okay. And you can see it says def print. So defining a print function. This is what came with and has all these different parameters or arguments and so forth. We'll get there. But the idea here is that we have a function. So when I say that we can also call functions on these strings is as follow. I can say message dot, and you can see then this happens. So I'm referencing a function on this message, which is a string. So I can, for instance, say upper as a function, which is going to make this an uppercase. If you hover over again, you can see it returns a copy of this string converted to uppercase. I'm going to put that also in a variable. So I'm going to say uppercase, just like that. And then I'm going to print this instead. So I'm going to say print this upper message or uppercase that is. Let's see what's going to happen. I'm going to save and go ahead and say control backtick and say Python 3 in my case and hit enter to run this. You can see it says hello there, this is good. Very good. So we did a few things here to assign things to a different variable. So we have a message here which says hello there, this is good. And then what we did is we took that message, which is all of this, and we called the upper function, which again returns a copy of the string converted to uppercase. And we put that into this uppercase variable, and then we printed that. You can see now it's really easy to play around with the data, in this case with strings and variables, because now we can change them as we go. And for here, I can also, from inside this function print, I can say lower, which is another function. As you see, you can imagine this will print a lowercase. So upper again, and hello there, this is good. So it's going back to what we had here. Let me go ahead and get rid of that altogether. And so I'm going to change this to Paulo like that. And so now what I can do, I can say print, and I'm going to go ahead and call, say Paulo, or actually its name, and I'm going to invoke the title function like this. Make sure you put parentheses to say that I'm calling a function. I want it to run. So what this will do, I'm going to save this and see what's going to happen. So I'm going to clear this and go up and run. You can see now Paulo has an uppercase P, which is not the case that we had before there. So the title, if you hover over, it says returns a version of the string where each word is title cased. That means I can do the same with our message, right? So now our message, each word starts with a lowercase, and I want to change that. Actually, I'm just going to call message as such. Save that, and let's go ahead and run. We should see, hello there, this is good. So the first letter of each word is now in uppercase. Very good. Imagine that you have a text or you have a string that is got spaces, so it's not very nicely or very well formatted. Now, there is indeed another function which is really handy that we can call on a string. It's called strip. So strip method, if you hover over again, you can see, returns a copy of the string with leading and trailing white space removed. Okay, so it's going to be leading and trailing. So let's see what's going to happen. All right, I'm going to go ahead and just save that. And let's go ahead and run. And you can see the spaces are removed from leading and trailing. Now, of course, it doesn't take away the spaces in between the actual text. There's probably something else we can do about that. But this is something that I just want to show you, because now, instead of having this space, when you run, you can see that there's no longer space. Now, it's hard to see here because we don't have anything, but just know that it got rid of all that space, right? Trailing and leading space like that. Okay, the other thing I'm going to show you here is there's this thing called string concatenation in different languages. What that means is sometimes we have variables. For instance, we say Paulo is here, that's name, and we want to write a message. And so we want to be able to pass inside of this string a variable. So reference this variable inside of this string. Well, in Python, we have this thing called f string. So essentially, we put an f before the start of the string, which will mean that inside here we can call these variables. Because if you don't put that, and I want to call this variable to say hello, like this, and then say name, which means I want to get this Paulo reference here, right? It's not going to work, as you can see, because it's going to look at this as a string. However, if we put an f string, and then to differentiate from just a normal string, we have to put inside of curly braces like this to say, okay, when you read this, compiler, this is a variable, which is that. So just pass in the variable contents. Okay. So now, if I just call message as such, and you can see hello, Paulo. And of course, I can go ahead and say title, for instance, like that, just to see the changes. You can say hello, Paulo, there, this is good. So everything now is back to what we saw before. Whenever you want to reference, in this case, a value from a variable, that's when you use an f string. It's called f string, which means you put the f outside of the first quote, and then whatever referencing that variable inside, you have to put that inside of curly braces like that. And so now you're given a lot of different things that you can do, a lot of flexibility, because now you can pass things around, you can concatenate them, you can pass variables, you can manipulate text or strings that way. Another important data type is number, because we need to represent numbers in programming. So how do we do that? Well, it's very simple. It's just like we represent strings. We can represent numbers. While I'm here, another thing you can do to create comments, which means it's something that it's for us developers to see and the compiler would ignore. In Python, you say shift and then pound sign and say this is a comment, which means this will be ignored. So anything that comes after this pound, you can see even the color has changed to gray. That means that's going to be ignored. So if I wanted to, for instance, comment this out, I can say command shift and then arrow right to select everything, and then I say command / like that. Okay, so this is different ways to do that. Okay, or I could just go in the beginning here and then put the pound sign to say that this is no longer going to be read, right? It's going to be ignored by the compiler. So let's go ahead and look at numbers. So for numbers, we have different kinds of numbers. We have integers, floats, and so forth. So let's start with integers. To create an integer, so a whole number, it's very simple. I can say, for instance, age, and set that to 23. So now age is holding the number 23. Very simple. I can add numbers. I can say sum of age plus 45. Forgot to put the assignment there. And then I can go ahead and print that. So if I say print sum, now you can see we have an issue here. Sum is this color, which is the same color as print. What this tells me is that I cannot use sum like this because sum is a reserved keyword. All right, so this is very important. Change this to total, something like this. Okay, and then I'm going to use total like that to be printed. Let's see what's going to happen. Let's go save and let's run this real quick. 68 because 23 plus 45, it is indeed 68. And in this case here, we can do all sorts of things. For instance, we can multiply. To multiply, you put asterisk like this. So age 23 times 45. And we can see that the results. And we can go ahead and check the results. There it is, the result, and so forth. We can also divide by putting, in this case, / like that. And test. And you can see it gives us this very strange number, which is a decimal point. So this is what we call a float type, right? A float number. So in this case here, every time you divide a number, if I were to change age to 100, for instance, let's see what will happen. Voila. So you can see that whenever we divide two numbers, whether there are whole numbers like integers as you see here or floats, you can see that the result tends to be a float. All right, so that's something to keep in mind. So now we have the basics of Python. We know how variables work, how to declare them, as well as some basic types such as strings and numbers. Really, those are the most fundamental data structures in Python or in any programming language. But we need more. So now we're going to talk about Python lists. So what is a list? A list is a collection of items in a particular order. So essentially, a list will be something like this. We can have a Suzanne, we can have 9, and even an emoji of a rocket. So the most important thing here to realize in Python, these items that are inside of this list are ordered, which means they have a certain order. And the other thing is that they can contain different items. You can see we have Suzanne, which by now you should know that is a string. And then we have 9, which is a number, which could also be represented as a string. And we have, in this case, an emoji, right? So let's go ahead and look at lists in Python. Okay, so to declare a list in Python is straightforward. Let's say we want to create a list of fruit. So we say fruit, and we set that to a list. So it's important to know it's a list, and we put that inside of square brackets. And inside here, this is where we're going to put the items of the list. So in this case, I'm going to use a list of strings. So I'm going to put inside of double quotes or single quotes, and I'm going to say apple. And each item in this list has to be separated by a comma. And then I can say banana and cherry, like that. Okay, so there we go, we have a list. So if I say print, and I print our fruit list, let's save, and let's go back to our command line here, or terminal, and I'm going to run. You can see we have indeed apple, banana, and cherry. Next thing we need to do here is to figure out how do we access each one of these items, because as you see here, when we print, we're just printing the entire list. What if we want to take banana? We want to get to banana. Now, to get to one of these items, singular items, we can just go ahead and reference the index for each one of these items. What that means is each item in a list is sitting at a certain index. So this is index 0, index 1, index 2. So everything starts at 0, not at 1. So if you want to get apples, this sits at index 0. So we'll just have to use square brackets again and say 0, for instance, like that. And this should give us apple. Let's see if that's true. Let's run, and you can see we have apple. And of course, if we want to get to cherry, 0, 1, 2, and then we just pass 2, save that, and run again, we can see we have cherry. Now, of course, with lists, we can also modify the list because we want, for instance, to add another items in place of item X or Y. We can do that. For that, I can say fruits. In fact, this should be fruits, not fruit. All right. So because it's a list, usually you want to put in plural. So fruits, and I want to modify index 0. So I put that like that, and I set that to, let's say, mango as such. Now, if I print fruits again, we'll see that we shouldn't have apple in place of the index 0. We should have mango because that's what we said here. We're saying go to index 0, which is here, and remove whatever is there and override with mango. And you can see now our whole list has mango, banana, and cherry. So no longer do we have apple. And of course, you could do the same if you want to change or modify banana, cherry, and so forth. Now, if we want to actually add instead of swap per se, well, it's a little bit different. So I'm going to go ahead and comment this out. Again, you can say Command, Shift, and then arrow left, depending, to select everything. And then Command /, and that comments this line of code, which is pretty handy. So now what we can do, if we want to actually add to this list, we can just say fruits, that's the name of the list, and we can use the append function or method. Very nice. So the append function appends object to the end of the list. So these are considered objects. We'll talk more about that. Okay, so it's an object, just an item in a list. I can put whatever I want. So let's say I want to add mango as such. You'll see the mango will be at the end of the list. Let's print that. And you can see we have mango there. All right, now, of course, we added. Let's see how can we, in this case, remove an item from our list. To remove, I can say fruits, that remove. There is the remove function or method, and I need to specify what is it that we want to remove. Well, I want to remove cherry. I need to make sure that cherry is written exactly as that, right? Because that's what I want to remove. Now, if I run this, you'll see that I only have apple and banana. Now, keep in mind, because I commented out mango, that's why mango is no longer there anyway. Okay, so I should have only apple and banana because I remove cherry. And the other way I can remove, I'm going to comment that out, something is by using another method. So the method we're going to use here, I'm going to say fruits again, and I'm going to use the pop method. What is this going to do? So remove and return item at index default is last one. So if we don't put anything here, we are going to just remove the item that is the last one, which in this case is going to be cherries. So if I save this and run, you can see cherry was removed, just what we did here, right? So if you know that you want to remove the last item, just say pop. Now, I believe that you can also pass the index. So if I say I want to pass the index 0, which means I want to remove this one here, the first one, let's see if that's going to work. And voila, we only have banana and cherries, right? Because we said remove apple, in this case, say pop 0. So we can pass the index which we want to remove the item from, or if we don't pass anything, it's going to get me or remove the last item as it says in the documentation here. So now that we know how to modify and reference lists, items, and do all sorts of things, I want to also to remind you that in a list you can add different types. For instance, this list is just a list of string objects, but you could add a number. That's the beauty of Python. We can reference all of them. So if I want to get the second item here, I go 1, and I'm going to be able to do so with no problem, right? If I run this, it says 2. And of course, this makes no sense because This is fruits, so 2 is not necessarily a fruit, but I just want to point something out here, right? Now let's have a little bit of fun here because we have some good grasp on the basics of F strings and variables and all the things. So let's say I want to write a message that says, hello, my name is X, in this case Paulo, and then I like apples or bananas or cherries. Simply, we can create a message variable here and then say something like, hello, my name is, say Paulo as such, and I'm going to concatenate. And remember, we need to do F string like that, right? So I'm going to put that like that. And now I want to say, I like cherries or cherry, right? So how do we do that? Well, first of all, we have to access fruits. So I'm going to say fruits. And I know that cherry is the last one. Okay. So I'm going to pass 0, 1, 2, right? A good cherry, like that. I think it's better. All right, let's save that. Now we can just print our message. Okay, hello, my name is Paulo, and I like a good banana. Ha! I made a mistake. Of course, I said 0, 1, 2. That should be 2, not 1. All right, you probably saw that coming, but that's okay. We can always fix things. Now you know that I am just a human. Okay, so hello, my name is Paulo, and I like a good cherry. Very good. So you can see now we put something to use, which is we have our list, and we are able to use f-string to pull information from list and make it a little fun. And what I can also do is, because this is in itself an object, I can also call a function on it. So I can say dot title, for instance. Look at this, right? So now, if we save this and run, instead of just a cherry with lowercase c, we should see something different. Look at that. I like a good cherry. Okay, very simple, but you get the idea. So figure out ways that you can play around with this concept so you can practice a little bit messages and lists and pulling information from our lists onto, in this case, an F string. Now, there are things that we always would want to do with lists of any kind, be it lists of integers or lists of fruits here, which are just strings. One of the things that we could do with lists is sort them. Now, let me create another list here called ages, and I'm going to put some random ages here, like this. So I think this will be a better way to represent all of that. So I'm going to just delete this, by the way, because we don't need them. Okay, if I say ages and get the function sort, start typing sort like this, you'll see, if you hover over, sort the list in ascending order and return none. So it's going to return nothing, but it's going to sort that list. So in this case, I'm going to pass ages.sort, and I'm going to pass anything, of course. And if I print ages again, first I'm going to print ages before, so you can see the difference. And I can put an F string here that says, look at what we are going to be using now. So I'm going to say before sorting, like that. And then I'm going to copy that. And one thing you can do to copy or duplicate a line, Command, Option, and arrow down, you can see that will duplicate that line and paste it down. Okay, and I'm going to select that whole line again. And then if I want to move that down, I just say Option and arrow down, and you can see it puts down. So I can move it around as I like. So this is just easier to deal with. I'm going to delete that. And so I can say after sorting, or just say sorted, like this. So now you can see before sorted, or before sorting, ages. It's going to show this, and then we'll see once we have sorted the list. Let's run. Okay, before sorting, we have that. And then after sorted, it sorted the list. So 12, 45, 56, and 76. So that was a list of numbers. And of course, we could sort, in this case, the fruits, but this is not going to show any changes because you can see this is already alphabetically sorted. But if we were to change a few things here, let's just put grapes and also mangoes or mango. Now we can actually sort that as well. So I'm going to just go ahead and say fruits. It's going to be pretty crowded, but it's okay. Okay, so we have that, but now you can see we have apple. That's alphabetically correct because A, B, C, G, and so forth. So this is indeed sorted. Now, what if you want to reverse this list? Well, you can do that as well, because now I can just, instead of sort, I can call this reverse like this, and we're going to print that. Let's see, just having fun. And you can see it's reversed. So instead of starting with mango, grapes, and so forth, it started with cherry, which is the last one we have. So cherry, banana, apple, grapes, and then ends with mango. And of course, you could do the same thing with any kind of list, really. Now, one last thing I want to show you here is that it's very important to be mindful when it comes to list, especially when we want to access something that doesn't exist. What that means is, let me go ahead and get rid of some of these. And if we want to print something, I'm going to say print, and I'm going to get the ages list, and I want to print the 10th index as such. Well, let's see what's going to happen. Let's run, and you can see that we have this error that it comes up, and we have the trace back. So the problem here, it says index error, list index out of range. Well, what that means is we are trying to access something that doesn't exist. Because if you look at our ages, we have index 0, 1, 2, 3, right? 0, 1, 2, 3. And so trying to access index 10, it throws that index error because it says, well, we don't have that index. Okay? So that is something to keep in mind. Whenever you want to access an index or item in an index that doesn't exist, then you're going to get this index error. Likely it tells you exactly where the problem is and which part of the code that is problematic. So that's very handy. Another important thing you might want to get a hold of when you're dealing with lists or working with lists is the length of the list. So how do we get the length of the list to know essentially how many items are in the list? Well, there is indeed a nice function I'm going to call list length or len, like this. And all you do, you just call the function called len, which is length, and then you pass the actual list. So if you hover over, this is a function that should return, this is another concept we'll talk about later, it returns the number of items in a container. A container in this case is a list, could be any other type of container, but just returns how many items are there, which is the length in this case. Okay, so that's really cool because now I can just say print here the list len, and it's going to give me how many items are in that list. 4. Indeed, 1, 2, 3, 4 items. Okay. So the len function, it's very, very useful for the reasons I'm showing you, because in many cases when you start working with larger data sets and so forth, you want to check the length of whatever data source you're getting. In this case, could be in a list format. So you want to check the length so you can do other computations and figure things out as the program goes. So you will see length many times. I'm sorry to interrupt. I just want to say thank you for being here. And if you're enjoying this course, remember that this course is actually part of a larger course where I go into more details, not only about the basics of Python, which you're learning in this mini course, but also how to actually use and implement Python by creating tools that you can actually use, like automation tools with AI, and creating graphs, parsing data, creating visualizations, as well as using Python to build web applications with Django. So the actual full course is about 13 plus hours. So if you're interested, and that would mean a lot to me, check the link in the descriptions to go and get the full course. Okay, thank you. Let's continue. So working with lists allows us to do all sorts of things, but most importantly, when it comes to programs, we're trying to automate things. We're trying to get things done fast without us having to intervene. And that's when we have structures such as loops and while loops and all of these different things, which allow us to branch our code and repeat certain tasks. So imagine that we want to print out the contents of a list, but instead of doing manually, we want to just go through, iterate through, and print all of the items out. As you see here, we are assuming that the list that we're getting is something that we know of. But in some cases, some lists are just lists that come from somewhere, and we have no idea. That's the point of programs. This is when we have for loops. This is fantastic. So with for loops, we can set it up so that we can go through, iterate through a list and do whatever we want to do. So to create a for loop in Python, we say for and then add, for instance, fruit. That's a variable. I'm going to say in fruits. And we put colon, and then we hit the return. Now, it's very important here to look at what's happening here. We say for fruit, think of this as the variable, which, as you see here, says a variable, which is going to be holding each one of these items as we go through. So we need to pass fruits because that is the list that we're going to iterate through, loop through. And colon is important because now we're saying enter. Now we have this indentation. Now, indentation is very important in Python because you see here we don't have curly braces and all these things to delimitate, in this case, certain parts of our code. So indentation is very, very important. So whatever we write here is going to be written as many times as it needs to, depending on the length, in this case, of our list. So if I just print something here, hello, for instance, look what's going to happen. Let's go ahead and open and run this. You can see it's going to call hello 1, 2, 3, 4, 5 times. Why 5 times? Well, that's because we have 5 elements. 1, 2, 3, 4, 5. So it's going to go through the length indeed of our list. So now I can make it even more exciting by say, for instance, I like, and then I'm going to actually make this an F string and then say fruit. So I'm going to pass the variable, which is going to be each one of these fruits as I go through. So this is what it's going to print. And I can put comma or period, I should say, like that. I clear this. And if I run, you can see it's going to go through the entire list and print out each one of them. I like mango, I like grapes, apple, banana, and cherry. Okay, so loops are really awesome, especially when we're dealing, in this case, with lists. Now, anything we write inside of this loop is going to be written or is going to be run, right? As soon or as long as the loop or whether the fruits list here contains those items. So if you want to write something outside of that, we just go back. Now we are at the same level as the for loop. Now we can just print something like this. We are out, and just make sure you can see outside of Fruitland. So now you can see if I run this, it's going to run all the things like mango, grapes, all the way to cherry, and then you're going to say we are outside of Fruitland because we are not inside of our loop. So whenever you want to break out or print something that is outside of our loop, make sure that indentation is very important. So you write that outside of that for loop, which means going to be at the same level as the for loop. So I went ahead and created a new file here called loop_nums.py. So you have access to this, but most of this stuff, I hope you can just code and not rely on having the code. But in any case, you will have access to at least some of the things I'm working on, the simple stuff, okay? So now we're going to look at creating numerical lists, which means we can actually create a list using for loops. So we're going to use a function, which we will look into what a function really is, but essentially it's something that we can call, run it, so it does something, right? So I'm going to say, for instance, for value in, right? And I'm going to pass this function range, And in this range here, I'm going to pass something. I'm going to say, what is the range? Well, I want to pass the value from 1 to 10, something like that. So what I'm saying here is that I'm going to have the same thing we've seen before. We have value in range, right? And the range is going to be from 1 to 10. Don't forget the colon. And we have the indentation here to say we're inside of our for loop. So in this case here, I'm going to just go ahead and print something. So this something is going to say, for instance, number, and I'm going to make this an F string because we know how to do that. And then I'm going to say value as such. So now, because I have a new file, so I will have to actually say Python instead of app.py. I'm going to say loop underscore number.py. So anytime you have a new file you want to run, you have to reference that file. Okay, let's run. Looks like I have an issue here. No such file or directory. Okay, loop number.py. It's loop nums. Okay, so that is another thing. So make sure that you specify the correct naming. Not numbers, nums. Okay, now you can see, run that. You can see that we have 1, 2, 3, 4, all the way to 9. Okay, so it's not inclusive. If I want to get to 10, I will have to say 11 as such. Save that and run again. We should say 10. Okay, so this is really handy because now we're giving all the work to our for loop. So we don't have to do it manually because in a for loop we can do that automatically using range. So we can use range, the function range, and pass the range that we want. Right? And so here you can actually put a huge number. You can say from 0 to maybe that number there, right? So let's go ahead and see what will happen. See how fast this is, and voila, was real fast. So that will depend on your computer, but you can see that you can generate very, very large numbers. Okay, now the beauty here, let's make this smaller, maybe 100, is that now that we have these skills, we can, for instance, create a list, right? Let's say we want to create a list that will contain numbers from 0 to 100, right? So I can create a list here of list nums, something like that, and I can make it empty to say this is empty. There's nothing in there. And then here what I can do is each time we go through, we're going to say list nums and use the append and append the value of those numbers. And then I'm going to just show, in this case, the list nums, which will have those values. Right? Let's go ahead and see. I'm going to have clear all of this and run again. And voila, you can see now we have this list of numbers that contains all of those numbers. Now, so what's happening now is that each time we loop through, we do that, but each list is going to increase and it's going to be printed 100 times, which is not what we want. So this print here has to be outside. So this is part of understanding how this works. So we have a list, we have to go outside in order for us to print the actual list once we have added 100, at least 98 numbers into our list nums. Does that make sense? So now this story is going to be different because we're outside of for loop. Then we should see our list nums, just one list instead of 99 lists containing 100 items, if that makes any sense. So I'm going to clear this and run again. Now you can see we only have one list, voila, from 0 all the way to 99. And the beauty here also is we can do all sorts of things. Let's say we want to make sure that as we go from 0 to 100, not inclusive in this case, before we add anything to the value, we're actually going to, before we append those value, we're going to say we want value. Again, we're going to get that value and we're going to set that to value and multiply that by 2. So each time we go through, we're going to get that value and multiply by 2 and put into the value, which then we're going to append that to the list. Right? So these are should be square numbers. Yes, indeed. So let's see what's going to happen. Let's save this and let's go ahead and run. And there you go. So you can see now we should have all square numbers. So 2, 4, 6, 8, 10, 12, 14, and all the way to 198. The other thing we can do, let's say we want to get the list nums at this point. Let's make this probably just to 10. And once we get the list, we know that we have the numbers, right? So our list at this point at the bottom here should have something. Let's say we want to work on all those numbers again that we get from a list. So I'm going to just remove this and just have the values as such. For now, let's go ahead and get the max number from our list. So what I can do, I can just say max num, and I'm going to use a function called max. So this is a function that already comes with Python. So I pass the list. So list nums as such. So now I'm going to print max num as such, and let's see what's going to happen. So I'm going to save this and run. You can see the max num is 9. Is it true? Let's, before that, go ahead and print the list itself. List nums like this. If we run, okay, so you see 0 all the way to 9. And of course, the max num is going to be none. So let's find the min num from our range. I'm going to say min num. I'm going to use the function min for minimum and pass our list of nums and say print, put f string here, min, and I'm going to pass our min num. Let's run. Min is 0. Makes sense because we have 0 as the min and the max is 9. Okay. What if we want to look at the sum? Well, we do the same thing. There is that function we saw before. I'm going to say sum total, use sum, and pass our list of nums. And I'm going to copy this and do the same thing. So option shift arrow down and sum, and pass the sum total, and go ahead and run this. You can see the sum of all these numbers is indeed 45. So these are functions that we can use that are pre-built in for us to do all sort of things. Okay, let's say we want to generate a list of even numbers. Okay, so how can we do that? I'm going to go ahead and comment this out here. So look how simple this is. So I'm going to say even nums such, and then I'm going to put that inside of a list so I can actually call the list like that. There is a function called list, and again you can have over built-in mutable sequence. If no argument is given, the constructor creates a new empty list. Okay, so in this case here I can create a list of numbers using range, just like we've done. So I'm going to say range. We've seen this, and then we put where we start. Let's say 0, we end at 100, but this is not going to give us a range of numbers that are even numbers. To get even numbers in our range here, we can also pass the third argument here, which is going to be by how many to skip. Okay, so we're going to say we're going to skip 2 numbers each time. So if I say 2 like this, this will give us even numbers between 0 and 100. Right? So let's go ahead and print this real quick. I'm going to put even numbers. Let's go ahead and run. And you can see we have a list of even numbers. Okay, let me make sure that we don't see this other one here. Comment that out, because that is what is showing there at first. So okay, let's do it again. So you can see we go 0, 2, 4, 6, 8 all the way to 98. So now we are saying we want to have even numbers. We put the range, and then we actually create the list by calling the list class here. This is actually not a function. It is indeed a class or an object that we're calling. We'll look into classes later. So this means now whenever you want to create an actual list that has everything, you just use the list class or object like this. So earlier, what we did, we created an empty list, which is what you saw here, and we loop through and we passed the range and we got to append those values and we got that list. So that is valid. But then because of how Python wants to make sure that everything is as easy and as straightforward as possible, we also have a list object we can call and pass the range and then do all sorts of things. Now, what if you want to create numbers divisible by 4 or 3 or even 10? Same thing. You create the range inside of a list and then you put by how much you want to skip. So if you want to skip 3 each time, then put 3, 5, and so forth. All right, so now we've seen how to create lists of numbers 2 ways, by using the list class or the list class or object, but also creating the list itself. Let's say I want to create a list of squares. We would create a list, an empty list, and then we would go put inside of a for loop here, for value in range, and say from 0 to 10 as such, and put colon and indentation, and then we would then use our list squares and then append each value as we loop through, and then at the end we would just print our list squares like that. So we see this working. Notice that I've changed back to app.py, and you can see that this indeed works because we can see that our list was created. Now this is wonderful, looks great. So this is valid, but we can simplify all of that with what we call list comprehension. It is a way for us to destruct everything, to make it as simple and as straightforward as possible in one line usually. So I'm going to say ls sqrs, okay? And then inside here, I'm going to say value, variable, and then I'm going to put the for loop. So for value in range, and I'm going to say 0 to 10, like that. And at the bottom here, I can just go ahead and print ls squares, right? The second one. These are the same thing. So what we have at the top here is the way we've seen, one of the way we've seen how to create a list of numbers. We create an empty list and then we loop through and start appending or adding those values into the empty list, right? But this is what we call the list comprehension. You can see just one line of code, we're able to do the same thing. So you can see, we should see the same result. So this is what we are getting from this line of code. So what's happening here? Well, we have the same thing we had before, which is the for loop value in range. We add the range, that's fine. And that is the same thing that is happening here. But we put that inside of square brackets to say we want to put all of these values that we're going to be getting into the list, right? And so what will happen, the squares is going to have a list, as you saw when we ran and we print things out. And so what happens that as we go through this for loop, all of these values are going to be added into this value variable. And so each time we loop through, this value is going to put the value here. So that way we end up with a list like that. So you will see a lot of this syntax here, and at first can be a little bit daunting, but that is exactly what's happening. Now you may say, okay, wait a minute, we say this is squares, but those numbers are not squares. Yes, you're right. So to make these squares, we will go ahead and multiply that by 2 to be consistent here. Okay, now we can see we have the actual squares. But the point is the same. We're now using list comprehension to make it way easier. In one line, we can get the same results as we did before here. We can say value is equal to value times 2 to actually make this a list, just to make sure. Or we can actually remove that and just multiply by 2 as we append them into the list. So far, we've seen lists like this. We'll say name, and we can say Paulo, James as such, just like this. So we've seen lists like this, which is really great. One of the great things about these kind of lists is that they are mutable. Mutable means they can change or be seen. We can remove things, add things, and do all sort of things. Now, this is great and all, but there are times in programming that we want to create a list that is not mutable, meaning is immutable, which means we can't really change that. And we can do that. In order to do that, we just put all of that inside of parentheses as such. So we remove the square brackets and we put parentheses. So now, if I were to say that pop, for instance, you can see that I can't even access that pop method or function because I can't do anything with it. I can't remove, I can't add anything, and so forth. If I try to say name append, you see I can't even get to that. That's good because that's exactly what I want to do. So now we can do all sort of things. We can do the same things we did with normal lists, immutable lists, such as if I want to get all of the items from our immutable list here, which by the way, this is called a tuple, which is immutable list. So I can go ahead and print name, should be names, and the same thing will happen just like any list. You can see we have Paulo James. Now you have to notice here, we know that the compiler also knows obviously that this is not a list, right? This is a tuple, which means we can't change. And we can see that we have our parentheses instead of square brackets. So just like we've done before, we can actually say for name in names, we can loop through, print, in this case, name. And we can go ahead and run, and you can see we get the same results as before. So we can do exactly the same things that we could do with a normal list, except, as I said, these are immutable, which means we can't do anything. Which means we can't modify. Let's say I want to try to add something. So names at 0 index, I want to change that to Gina as such. And let's remove this. If I try to run this, like anything, you can see we're going to have an error. Say tuple object does not support item assignment, which is exactly what we said. All right. So tuples, again, if you want something, a data structure that doesn't allow you to change anything, then you would go with a tuple. So these values are not changeable. They're immutable. You can loop through them, extract things from them, but you can't add or remove and so forth. So programming usually involves branching, which means we want to have certain logic that will run depending on certain conditions. And so if statements, that is part of branching, and that is what we're going to be looking into right now. So the idea is very simple. We'll have a condition, and that condition, if it's true, then we want to do something else. If it's false, then we want to do something else. So that is, in a nutshell, and what an if statement is. Now, as simple as this may be, this is the foundational paradigm in programming, because the idea in computation is that we are dealing with data, and then we need to figure out ways in which our programs are able to decipher certain conditions and do certain things at certain times with those conditions, according or depending on those conditions. So imagine we have a variable called weather, and it's just a string that says rainy as such. We can check this variable to see if it's equal to whatever we want to check for. So I can say if, right, if statement, and then I pass in the weather variable, and I say equal. This is double sign to check for equality. If it's equal to rainy, like this, and then I want to do something. Let's make sure that we have the indentation. That's very important. And then right now, we'll just go ahead and print. Let's say, don't forget your umbrella. Like this. Now, you can see that it's complaining because I forgot to add the expected colon like this. So what happens here is that this is going to be evaluated as an expression, which is going to be a condition. In this case, it's going to be either true or false. And that is actually a different type of variable data type, right? These are called Boolean. So this is going to be evaluated into Boolean to either true or false. If this is evaluated to true, then whatever is enclosed here is going to print. Let's save and see if this is going to work. So I'm going to go ahead and run, and you can see, don't forget your umbrella is shown here. It is important again to see the distinction here with double equals versus single equal. This is indeed assignment. So assigning rainy to this weather variable. Now when we have double equals, that is comparison. So we're comparing this weather here. If it's equal to rainy, then we can do something. Now programs then get a little bit complicated or more involved because we want to make sure that at this point when we run this, we see don't forget your umbrella. But what if it's not equal? So it's rain, for instance. What's going to happen? Let's go ahead and run. We see that nothing is printed. Okay, in some cases that could be fine, but we want to account for times when this is not true, meaning when this is false, which is not going to run what's inside here. It needs to run something else. But because we don't have anything else to run, that's why we see nothing. Oh, well, we're in luck because there is indeed the else statement, which we then can run anything that is not caught in here. So I'm going to print something else. Let's say grab your sunglasses, something like this. So now if we go and run this again, we're going to see grab your sunglasses. Why? Because this is not true, and then it's going to run the else, whatever is under our else branch. So now we're able to create this conditional branching here that allows us to do even more. Now I'm using here rain or rainy or a string per se. I could have, in this case, let's say age, and age is 12, for instance. Okay, let me go ahead and comment this out for now. And so now what we can do, I can say if age is greater than 10, I can just print something that says you're older than 10, something like this. Right? Else, let's put this there, print you're younger than 10. So now we have this greater than sign here. So if age is greater than 10, then we're going to print this. Else, we're going to print that. Let's see what will happen. Okay, you're older than 10 because indeed age is 12. Now if I change this to less than, you can imagine what will happen. Let's go ahead and run again. You're younger than 10 because this, of course, is not going to be true. All right. So the thing to keep in mind here is that in if statement, what we need to pass this condition here, it will be evaluated as a boolean, which is true or false. So boolean in this case is going to be a true or false variable type or data type. So I can say, for instance, is tall, and then I can set to true, or I can set it to false. So now in this case here, this is a variable that is a boolean. It could either be false or true. So now I can actually use that here. Now, because this is straight a boolean, I don't have to do anything else. I could just use it. Say is tall, like that. If it's tall, of course, we can say something else, and then I can change this to not tall. Okay, just some differences here. Now, you may say, well, why is it that we can just pass in like this? Well, the truth of the matter is, as we said previously, this has to return true or false, right? Well, this is either true or false because it's a boolean, so we can just pass that. The thing here is I can change this to true, for instance. Let's go ahead and run this real quick. Okay, you are tall because indeed is tall is true. And you can see if we change that to false, of course, we will see that indeed the not tall is going to run. So here's a quick introduction of if statements, which is the beginning of learning about branching in Python. All right, now we can even create a more prolific extended branching in Python by using the else if. So imagine that we have this variable here called temperature, which holds is about 65. So this is Fahrenheit. That is mildly warmish, okay? Not too warm, but not too cold, just kind of nice. And so now I can put an if statement here to say if temperature is less than, say, 45, I'm going to print something. And so I want to say wear a jacket. That's very good. But then I want to also be able to capture another condition here. I could go and say else, but the problem with else is that I cannot add a condition that I want to check, right? Because just say else, if nothing is equal to whatever that we are comparing here, then we're going to run whatever is below here, right? But we can use the else if because we want to check for another numerical value, another condition, another expression that will return a boolean, right? So I can use the else if. So you say L if like that, and then we pass the condition. So what is the next condition? Well, else if the temperature is less than 60, then I'm going to print a t-shirt is fine. Okay. Now, to finalize everything, that's when I put an else, because now we no longer have anything else to look into, right? To evaluate. So now, if none of these is caught, then we are going to go to the else. So I'm going to print, in this case, it's warm, stay cool, something like this, right? Now, of course, these numbers are very relative, depending on the people, but you'll get the idea. Let's go ahead and save and see what will transpire from this. Let's run. Okay, it's warm, stay cool. So temperature is 65, that's where we start, and we're checking if temperature is less than 45. So 65 is not less than 60, so this is not going to run. But the else, because none of these is true, then the else is caught, and that's why you see it says it's warm, stay cool. So you can see here now we've introduced the else if. So whenever you want to continue to check for a condition, then you can use the else if, and at the end you are going to cut everything that wasn't caught under the else. And another example is, imagine that you have, let me go ahead and comment that out. Let's imagine that we have a list. It's called participants, and this list is a list of names. We have Bob, Jerry, Ahmed. I want to check if in this list we have a certain person or a certain name. So we can use the if statement. So we can say if Bob, look at that, we can actually pass the string itself. If Bob in the keyword participants, then we can do something. So I'm going to go ahead and print Bob is registered for the event. Else we can print Bob isn't registered, like that. So now let's go ahead and save. And you can see Bob is registered for the event because indeed Bob is part of this list. Now this is really cool because we can just say in, use the in keyword and pass in the list to check indeed for whatever we're looking for. So it could be Bob, it could be Jerry, or whatever it is that you're looking for. So if we had a list of numbers, we could also go ahead and do the same thing. So it's really, really powerful, and Python makes it really simple for us to create these branches in our code. All right, let's do a little fun exercise here, fun hands-on. So let's imagine that you're organizing a weekend outing and have a list of activities, as you can see here: hiking, swimming, museum, picnic. And you also have a list of group of interest or group interests. So we have art, history, and swimming. Okay? And you want to choose activity based on the interests of the group. So how would we do something like that using what we know with if statements, else if, and so forth? Okay, so the first thing we'll do, okay, we're going to go ahead and check if an activity aligns with group interest. How do we do that? Well, we put in if statement. So I'm going to start with the museums. So if museum in where it's in under the activities list, and I'm going to put that inside of parentheses to say we're going to use more than one statement or more than one condition here in group interests, and then I'm going to use or. I know a lot of keywords here, it's okay. History, group interest. Then I'm going to go ahead and print something here. We should go. We should visit the museum. Okay, I'm gonna make this a little bit small so you can see the whole thing, hopefully, and probably put this in a new line so perhaps we can see. Okay, so what's happening here? Now, a few keywords that we haven't seen. So we're checking here if museum in activities is true, that's what we're saying, and the and keyword, we then look at this entire expression here. We say if art in group interest is true, or history is also true, that is from the group interest, then we're going to say print we should visit museum. So there's a lot of things that are happening here. So let's divide everything into smaller pieces. So the great thing here is that we can actually check multiple conditions in one go. So what we're saying here is that we want to check this condition first and want to check this whole condition, but this condition has even more conditions inside, right? So we're saying, well, if museum is in activities, so the activities is this list here, we have museum, if that's true, which is true, and this other condition here has to be true in order for us to be able to say, well, we should visit the museum, right? And so if we break it down, the second part here, which we're looking for art. We say, okay, if art is inside of the group interest, which is true, we have, or history is inside of this group interest, either or, then this should be true. Which means then we take all of this and say and whatever we're getting from here, and then we decide. So let's go ahead and play a compiler and see. So this first condition here, I'm going to copy that and put here. So this is going to be true. Okay, like that. And then we have this whole condition here. Let me copy that. Paste it there. So this whole condition here is going to also be true because art or history are part of our interests list. So that's why this is going to be true. Now taking this whole condition here, we're going to have what? We're going to have true and true. So if we have true and true, the result is going to be true. That's why this whole thing condition here is going to yield to a true. That's why we should visit the museum should work. Okay, let's go ahead and run this real quick so we can see. And indeed, we should go visit the museum. We should visit the museum is going to be written. Okay, let's continue here to finalize this entire thing. I'm going to go to save. All right, now I'm going to say else, or else if, that is, if swimming in activities and swimming is also in interests, or I would say group interests. If that's the case, then we're going to go ahead and print something looks like a day at the pool is in order, something like this. And in any other case, else, we're just going to go ahead and print, let's plan a picnic instead. Let's go ahead and run real quick and see. Okay, we should visit the museum. That is exactly what is going to show. Right, we can also check for inequality in Python because that is also valid. Imagine that I have a variable age. So I'm going to say age 23, And so I can say if age is not equal, I want to check for inequality. So you say exclamation mark as such and equal. To say not equal to 23, then I can print not 23. Okay, very simple. Let's go ahead and run this just for completion. And of course, you can see that it's not going to show that because 23 is actually equal to 23. So if I say 22, for instance, you will see that this should say not 23. Okay, so we are checking for inequalities for numbers, but you can also check for inequalities when it comes to if you have, for instance, a string. So imagine that I have topping string here, and I can put that in a list. For instance, I can say olives, tomatoes, like that. And I can also check. So I can say if toppings, I should say toppings, and I'm going to get the first one is not equal to, let's just be silly and say mangoes. Then I'm going to go ahead and print no mangoes for toppings. Something like that. Comment that out. And let's go and run real quick. No mangoes for toppings. So you can see, very simply, you can use the exclamation point and equal to say not equal, like this. All right, so with if statements, else if, and all of these inequalities checking and all these things we've learned, you can do a lot of great things, create programs that are very sophisticated. So let's look at another real world per se example here. So imagine I have a variable day here, and the day is Saturday, like this. So essentially I want to create a nested if statement that will check whether if it's Saturday, and then we are going to see if we're going to have breakfast, what kind of breakfast we're going to have, if it's an elaborate breakfast or just a quick one. Okay, so I have day, which is a Saturday, and I'm going to create a list here, which is the fridge contents. So these are the ingredients that I have. So I'm going to say fridge contents, and it's a list. Of course, I'm going to go ahead and add, let's say eggs, and I'm going to say bacon. So now I can go ahead and check here. I'm going to say if day is equal to Saturday as such. What I want to do, well, I want to check to see what do I have in my fridge if I have the correct ingredients. So I can add another if statement, right? So this is an inner if statement. So I'm going to say if eggs are in my fridge, look at this, but I don't want to check just for eggs. I can say eggs and bacon in fridge contents. If that's true, make this smaller so you can see. If that is indeed true, then, well, I'm going to print something, let's say, that says time for a hearty breakfast. Now, I'm going to also add an else here. If that's not true, then I'm just going to go ahead and print maybe just cereal today. Now, you notice here, this else is for my inner if statement. But I also want to have another else for my outer, which is the one here where we're looking at today. Well, so if it's not Saturday, I also want to be able to print something. Say stick to the quick breakfast, like this. All right. So there we go. So you're going to check if today is Saturday. If that's true, then we're going to check what we have in a fridge. So if we have eggs and bacon, then that's good. We're going to print this. Else, if we don't have that, then we're going to just say maybe just cereal today. Now, else from our day. So if it's not Saturday, any other day, then I know it's time. It's probably a day of work. So I need to just go ahead and do a quick breakfast. All right. Let's go ahead and run this just to see something simple to play with. And you can see it's going to say time for a hearty breakfast because indeed Saturday is the day. If I say Sunday, obviously you know what will happen. And run this again, stick to the quick breakfast routine. So what I want you to do is to think of other ways or other small day-to-day life, real-world example that you can use with what you know so far about Python, if statements, branching, and checking for inequality, lists, and so forth, and see what you can actually create. So it's pretty fun. It's nice to get those fingers working. All right, so we've just looked at two keywords that we probably haven't seen before, assuming you've never done programming before, and so forth, which are very important. We saw and, or. So these are what we call logical operators. So essentially, they deal with logic, right? They yield either true or false. So for the and operator, if one side is true and you say true and true, you get a true, right, as the evaluation of the expression. Now, if you have a true and a false, you always get a false. For the or, if you have true or true, of course you get a true. Yet, if you have a true or false, you always get true. So for or, that's very important to remember, it returns true if one of the statements is true. So if this statement is true, doesn't matter if this is true or false, it's always going to be true. Now, there is another operator called not. So what not does, it reverses the result, which means returns false if the result is true. Let's now talk about dictionaries. Dictionaries is another data structure in Python that allows us to connect pieces of related information. It's real powerful, as you will see. So a dictionary in Python is simply an unordered collection of data in a key value pair form. So it's really similar to how you might use a dictionary in real life to find definition of a word, right? So you have the key, which is the word, and the value is the definition of that word in a dictionary. So Python dictionaries are used to store data values like a map. So essentially, you can see we have name, that's the key, and Joe will be the value. Age is the key, and 78 will be the actual value. And this would be the actual representation, as you will see in a second, when we create a key value pair, in this case, a dictionary in Python. Okay, let's go ahead and see how to declare a dictionary. So to declare a dictionary, for instance, I'm going to start with this variable here called full name. Okay, and then we set curly braces as such. Notice the difference here, curly braces, and then we put the key value pair. So I can say, for instance, name. Actually, let's say Paulo, and then my last name, Dishon, like that. All right, and I can continue. Let's say Gina and colon. Then we pass the actual value, Nelson, like this. All right, so there we go. That's how you create a dictionary. Notice we have the curly braces, and then we have the key value pair. So the key, in this case, is string, and we have to put the colon to say now we're going to create or add the actual value. Okay, so you can add as many as you want, and all of them are separated by comma. Okay, and of course you would go ahead and print that by just saying full name and run. You can see we have indeed our dictionary. You can even go ahead and create a different one here. Let's say person as a dictionary. Let's say we have name as a key, and the value is going to be Alex. And then we could have age as a key, and value is going to be actually an integer. So let's say 34. And let's add city. Say New York. All right, same thing, and I can go ahead and print person, and the same thing you will see. Now, the next thing here is, of course, how do we access our dictionary? To access our dictionary, it's pretty similar to what we've seen before. So first of all, let's go ahead and say print, and inside here, I'm going to say person, dictionary, and then we put inside of square brackets, and we pass the name. Of course, in this case, it's going to be the key. So you can see we have age, city, or name. Let's go ahead and say name first. So this will go ahead and look at person and find the name key, and we should return the actual value. Let's go ahead and run, and you can see Alex. The same thing you would do if you want to get age or city. The important thing here is that you have to pass the correct key, because if you pass the wrong key, let's just try it real quick here and run, you can see it will give us that error, say key error num, which indeed it doesn't exist. So it's important to always remember to pass the actual key to get the value. Now, the beauty here is that we can also access these values from a dictionary differently. So this is one way of accessing. Now, the problem with that is that, as you see here, if I put a different or I make a mistake for the key, I get that error. Now, there is another method we can use to get access to a key, in this case, to get the value in a dictionary, which is called the get. So the get, it's pretty awesome. It saves us from getting those errors if we don't find or if the key we're passing is not actually mapping to what we need to get from the dictionary. So I'm going to say print again, and now I'm going to say person.get. So you can see there is this get method. If you hover over, it's a method get, and it should return something. So what I'm going to get, well, I'm going to pass here the item that I want to get. You can see it says key is going to be the string that I need to pass. So the key is age, just to differentiate. And we should see, if we ran this, 34, because that is indeed what we're getting there. However, if I say AG like that, let's see what will happen. We made a mistake and run, it goes and says none. None, just to say we can't find that item. And so I'm going to return none, okay? So this is way better than that error that we got previously by saying key error, because we added num. Whenever you want to be sure that you are getting something, and if there's some issues with our key, maybe it doesn't exist, then you should use the get method to get items from our dictionary. Let's see how can we modify a dictionary. For example, let's say we want to add values to a dictionary. So we have our full name here. We can just get rid of that and just keep the person. So if we want to add something to a person dictionary, we say person, and then of course we access, in this case, let's say we want to add email. So this is going to be another key that we're adding to our dictionary. And then we're going to set the actual value, say alex@gmail.com. I apologize, Alex, if you are watching this video and you may end up getting a lot of spam, but it's okay. All right, so there we go. And now we print. Actually, I can use this previous print here and just get the whole dictionary. We should be able to see that, voila, email was added and the value is alex@gmail.com. Of course, we want to also be able to add something else. Let's see if we want to add a person is employed, such. So whenever you see is, anything that starts with is something, that usually means it's a Boolean. So I can just go ahead and say true like that. So we can even add that as well. So if you save this and come back here and run again, we can see that we have the field is employed to be true. And if we wanted, we can also modify a few of these entries, right? A few of these keys. So let's say I want to modify name here to something, or perhaps age. I can do the same. So I can say person. I'm going to get age. I'm going to change the age to maybe now Alex is 35. If you go ahead and run this again, you can see that age is now 35. Equally, let's say we want to remove items from our dictionary. Well, to remove an item, let's say we want to remove the age, the key value pair. We just say person, and I can say pop. Now, pop here allows me to pass in something. So we're going to pass the value that we want to remove, right? So what is the value, or actually what is the key that we want to remove? That is what we need to pass, okay? So we're going to pass the key is age, and we still have our print person. Now, if we ran this, we should see that we no longer should have age key of course, the value also will be removed. Now, there's a difference here. We have pop, which then we pass the key to be removed, right? Which, of course, incidentally will remove the value. We can also use another method called pop item, which will remove the last item. So let's go ahead and comment this out real quick. And now I'm going to say person, say pop. See, there is pop item, which allows me to, we don't have to pass anything because as you can see, if you hover over, it's just a method with no parameters. So it's going to return a tuple. We know that the last item is the city. So what's going to happen now? Let's go and check it out. And as you see here, we no longer have the city and the value. Let's say you're done with some parts of your dictionary and you want to actually delete completely, not just remove them, right? But just completely delete from memory, from everywhere. Well, to do so, you use the del keyword, as you can see there, and say pass, and then pass person. And then you want to pass in what you want to delete. So I want to delete the name in this case. Let's delete the, yeah, why not? Let's delete the is employed, okay, like this. So this will completely delete the is employed item in our dictionary. Let's go ahead and check and see that we no longer have the is employed. The other way also, if you want to just clear the dictionary itself, you can clear it by invoking the clear method. So I can say person and get the clear. So this just clears everything from that dictionary. So now save this and give it a run. We should see an empty dictionary. Now, how do we iterate through or loop through a dictionary? So let me go ahead and get rid of all of that. And let's go ahead and also get rid of this. And I'll leave the rest there. So to iterate through, I'm going to use the for loop, of course. And there are different ways to iterate through depending on what we want to get. So we can iterate through the keys so we can get the actual values, right? Because it is key value pair. So I can say for key in person, and then I'm just going and print something that says key. So now we're going to go and get all of the keys. And let's run. We can see we have all the keys: name, age, and city. So remember that we are going through and just getting the keys in our person dictionary. Now, if you want to iterate through values to get the values, then it's a little bit different. Because now what we can do the same thing, but now we have to point to a different thing per se. So for, instead of key, I'm going to say values. Doesn't matter what name you pass here. I'm going to say value in person. Now I have to say person and then dot values. So I want to say that I want to go and get those values. So it's a method function as such. If you have over already, always you're going to tell you exactly what's happening here. So dictionary values, string, and any. So, and tells an object providing a view of these values, which is a dictionary's values. Okay. All right. So let's go ahead and print our value. So each time we iterate through, this time is going to be the opposite of what we had here. So we're just going to see all of the values. And there we have Alex, 34, and New York. So these are different use cases. And there are times, of course, we want to get both keys and values. All right, we're getting there. So what you can do, say now for key. Aha, this is a good moment for you to see the things that you can put in your for loop to get what you need. So I want a key, and then I want the value. All of that from our person dot items. So this is very important, dot item. So the difference here is that I'm not going to just say person like this and expect to get anything. Let's see what will happen if we try to do that. Let's just go ahead and print key and value like this. Let's see. Let's run, and we have issue. It says too many values to unpack. All right. So essentially what it's saying here is that we need to go to person, which is just a dictionary, but we need to go to get the actual items function or method, which will give us what we need. So it's a function, so don't forget to add the parentheses like this. If we hover over, a set-like object providing a view of these items. So it goes ahead and get the dictionaries items inside. And now we can print the key, comma, value. Let's see. And there you have it. We have name, Alex, age, city, and so forth. And because of what we already know, we can even make this even better. So I can put that inside of a if f string, that is, as such, and then I can just say, put that inside like that, and put an arrow, and put that also inside like this to make it even better. Okay, let's run. You can see name, key, value is Alex, age 34, city New York. Now, dictionaries can also be a little bit more complex. For instance, we can have a nested dictionaries. So imagine we have a family dictionary. So a family would have a mom, and then also it would have a dad. So in this case here, for mom, we can have, of course, a key, which is mom, and then the dictionary here also that would represent a key, right? So inside of this dictionary, we can say, for instance, name Gina like this, and let's say age 78 like that. And for dad, we are going to also create yet another dictionary that will have, let's make sure that this is like that. The same thing, we're going to have name, age 89. And we need to put a comma there. So now we can see we have a little bit more complex dictionary. So we have a dictionary within a dictionary. So we have the main dictionary, family, and inside we have a key, which is mom, which indeed has a dictionary itself. So in this case, mom has a name, Gina, and age 78. Dad has a name, Maba, age 89. So let's see how to loop through to get certain items. I'm going to use the for loop. Now, because of the structure that we have here, we have a dictionary inside of another dictionary. We can extract a few things. So I can say, for instance, for name, I want to get the names of each one of this person. And also I want to get, say, information in family dot items like this. So now I'm going to be able to go through. So let's first go ahead and say print, and print the name and information just to see what will come out. Let's run this. Okay, so you can see now it's the name is going to say mom. Then we have our inner dictionary, and then we have dad. We also have our inner dictionary like that. This is real cool. So you can see that we're able to extract the correct information that we want. Now let's say we want to probe in and write something that is a little bit nicer than this. Well, I can come here and say, for instance, say print, let's say parent type. Then here I'm going to actually make this an F string, right? And I'm going to pass the name variable, which is going to be exactly the parent type. And then I want to have a new line to make sure that we have things organized well. So to add a new line, I'm going to put backslash like this and put n. Actually, that has to be inside of our string like that. So to say, just carry on, give me a new line before we print the next thing. Say parent name. And to get the parent name, in this case here, I just want to get this name here. So what I would say, and all of that information is going to be inside of the information, right? As you saw earlier here, information, this dictionary here. So we're going to probe in and get that information. Because I know it's just a dictionary, so I'm going to go and access name, which is going to be, in this case, Gina, and next Maba. So I'm going to go like this and pass in the name. As such, get rid of this, and let's save and see what's going to print. Actually, print parent name. Let's see. Okay, so you can see It goes parent type is mom, her name is Gina, parent type is dad, his name is Maba. All right, so a little bit of issues with spacing and everything, but no worries. At least we see that we're getting the right information. We'll fix that. Okay, let's remove that new line there to make it even better. So, okay, so we have parent name. And what I'm going to do, I'm also going to put inside of F string all of this here so I can get the correct formatting and correct information like this. So, parent name, I'm just going to go ahead and say name, give it like that. I'm going to copy all of that, Command Shift arrow, and then Option Shift arrow down to copy the same thing. Let's get the age for each parent. So go ahead and change the age. So once we have extracted the information that we wanted, now we can go ahead and display it. So before anything is printed, I'm going to escape a new line or create a new line like this for parent type, and then start putting everything together. And now here, I'm going to print, put an F string, \n for a new line. And let's pass parent name. And then at the bottom here, I'm going to use what we have already. This is going to be F string again. And we are going to add a new line before we print this. And we're going to pass the parent age like this. So we are essentially passing these variables to show everything nicely. Okay, let's just run this and see what we're going to be able to see. Okay, so you can see here, let me put this perhaps to the right. Okay, so we can actually see this better. All right, so you can see we have here parent type is mom, name is Gina. So I think I am repeating everything here. Let's just make sure. And this has to be parent age. All right, let's go ahead and run this real quick so we can see. Okay, so now it looks real good. Parent type is mom, name Gina, age 78. And then we have parent type is dad, his name is Maba, age 89. All right. Okay, so you can see that we were able to loop through a dictionary that's a little bit more complicated, a dictionary within a dictionary, and we pull all of the information that we wanted. Now, this may seem a little bit complicated at first, if it is your first time, but just remember, all we're doing here, we are separating all the pieces that we want to get. So we want to get name and information. So information, as you saw before, it's going to just have the information for each individual dictionary for each one of these mom and dad, right? And then we just separate the parent name, we remove that, and the age. And then we put it all together to print. That way we have something like this. Now imagine we have yet another complex dictionary here that contains, in this case, lists instead of having other dictionaries within a dictionary. So this is what you probably will see, a combination of this and what we saw before. So dictionaries instead of dictionaries, which also would have lists inside. Okay, so it's very simple here. We have speakers dictionary, which contains this dictionary that contains, in this case, as the key, its own list, right? So we have the speakers, Alice Johnson, Bob Smith, Carol Lee, and they have the things that are known for: Python best practices, machine learning, intro, and so forth. Okay, so let's see how we could, in this case, loop through this. We can do essentially what we did before with a for loop. So I can say for, I can say speaker, and then I can also have topics. So each speaker has topics. In speakers, that items, and then I'm going to print. I'm going to put inside of F string just because I want to be able to format and pass in variables. So I'm going to say speaker, say will talk, and I'm going to put colon there. And I'm going to also add yet another for loop inside here. This is the beauty. We can put all these pieces together so to get the result that we want. So I'm going to loop through again, in this case, the topics list. So for topics, actually for topic, in topics, we want to just print another F string and pass in the actual topic. So I'm going to just put a dash and say topic that we are getting like this. Okay. So first you can see we go through this for loop. We have speaker and topics that we are getting from the speakers here, dictionary.items. And then first we go ahead and first we just print out will talk. And then inside I'm going to loop through the topics list, which we're getting, because this is a list indeed, that we are putting in this variable as we get through each one of these individuals and get their list. You see? And then we print their topic. Okay, so now you can see the power here. So I'm going to go ahead and clear this. Let's go ahead and run real quick. And what do you see? We can see now it says, let's go back to the top, Alice Johnson will talk. We have Python and machine learning, because this is indeed what she's known for, right? That's her topics. And for each one, for Bob, you can see for Bob, we have cybersecurity, fundamentals, and of course we have Carol Lee, data visualization techniques, advanced SQL queries, and so forth. So this is exactly how we can manage to do things with dictionaries that are simple, but also dictionaries that are a little bit more complex in nature. So you can see that this is probably what you will see, a combination of inner dictionaries inside of dictionaries that contain lists. So this we will see at a later time in this course when we start parsing through JSONs and so forth. But that's okay. But at least we now know how to probe in and retrieve information from a data source. In this case, it's just a list. All right, so far we've been looking at the basics of Python and we've learned a lot. So now let's look at user input as well as while loops. So usually programs, they want to be able to get information from the user so we can then take that information and do some computations. That is the fun of autonomous programs, right? So that is what we're going to be looking into right now. User input and eventually while loops. Let's get started with user input. Okay, so imagine that we want to prompt the user and get some information from the user. Here's an example. So I can say name, and in order for us to get an input from user, we can use the input method or function that comes with Python. Very simply, just start typing input as such. And I know this is a function from Python, obviously, because it's changed color. All right, so what we'll do here, I'm just going to add a prompt. Just get rid of, I think I did something strange. Let's add a prompt here that says enter your name. Right? Okay, let's go ahead and say Python 3app.py. Okay, so it says here enter your name, and I can enter my name, Paulo, hit enter. Okay, so we were able to enter our name, in this case my name, but what will happen? What happened there? Well, it so happened that we essentially don't have a way to capture that name. We were able to be prompted to enter the name, we did, but then there's nothing else that happens. So, of course, that is not what we want. But what I can do now, just to show you that that name was captured, because it's going to be captured by the system, and we're going to pass it to this variable name. So, to show you, I'm going to print what we just captured, put inside of f string here, say your name is name as such, and let's be a little bit excited, and there we go. Let's see now. Okay, enter your name. Say James this time, and voila, you can see now it says your name is James, because we're able to pull that name from our input function here, and then we pass that information here. Now let's say also what I want to do is I want to capture the age. So I can say age, I'm going to use input again, and I'm going to ask how old are you, like that. And in this case here, let's go ahead and print. Actually, I can just print all inside here. Your name is that, and you are, I'm going to pass the age as such. Okay, let's see how this will work. Let's save that and just clear real quick. Let's run. Okay, so you can see, enter your name, say Paolo. How old are you? Say 38. Okay, so your name is Paolo and you are 38. Very cool. So you can see that you can do all sorts of things, and now you're able to get those inputs. Now, the thing here that we may not realize is that, okay, so in this case here, if we print something like this, I'm going to go ahead and say print because I want to show you something. And I can invoke this type class actually. So the object type, and you pass in something and it will return something. So if I say type and pass in the object, in this case it's going to be the age, let's see what will happen. Okay, so let's go ahead and run one more time. So what's your name? James. How old are you? 89. Voila. So you can see here, everything is working as we expect. However, when we look at the class here, it says class very strangely and str. What is going on here? Well, str stands for string. That means that this age here, when it comes in, all of these inputs, they come in as strings, which means if I wanted to say, for instance, for some reason, I want to multiply the age that's coming in by a number, say mult, something like that, and I'm going to say age times 45, for instance, and try to print that, which in this case is going to be just this mult. As an example, let's see what will happen. I'm going to go through the motions. And you can see your name is James and you are all of this. So it turns out that what's happening here is we have a string, if you hover over again, and then we have an integer. And so there's some confusion where we're taking this 45 multiplied by the string, which is giving us this very strange number there. So 45 times 89, it's not that. This tells us that something is not quite right. The reason being is because we have a string and we're multiplying that string by 45. The happening is that it's taking the same number and repeating 45. In this case here, that means we need to figure out a way to transform whatever we're getting from our input into an integer. And we can do that by putting an int like that and putting everything into an integer. So that way, all of this that is coming in that will be entered is going to be transformed into an integer, which if you have over now, you can see this age is indeed an integer type, as you see here. And that's exactly what you want. So now if I save this and I rerun this, you can see I'm going to say James again, and let's say 12 or 13. And now you can see that it makes more sense because now it's multiplying 13 times 45, and that should be probably the correct number there. So it makes much more sense. So that is something to keep in mind, is that anything that comes in from our input, right, when we add something, it's going to be a string. So we need to convert that into an integer in this case to get the result that we want if we want to multiply or do anything else with that number. All right, so let's do a fun little program here. Ask users to input a number, and we're going to figure out if that number is even and so forth. Okay, so I'm going to start here. I'm going to say number, and I'm going to put that inside of an input, right? So this is going to be enter a number, and I'll tell you if it's even or odd. Okay, I know it's kind of hard to see everything because I'm pretty zoomed in, but there we go. And what I'm going to do next is I'm going to take this number that we get, because as we know, this is going to come in as a string. We want to convert that into an integer. So I can use the same variable, which will override whatever we're getting here. So you can actually say something like a number and say int and pass our number. So this is the beauty of Python, is that how this is going to be read. We're going to get that number, and we can use this same variable as the one we created at the top here, and then we're going to override it with now an integer. So now this number here, if I have over, it's going to be an int. However, this is a string in the beginning. And so now I'm going to put an if statement here. So now how do we check to see if a number is even or not even? there's this operator called the modulo operator, which allows us to use the percentage sign to find the remainder between two numbers. And that's going to check if a number is odd or not. So I'm going to put if statement here, and I'm going to say if number that we're getting, I'm going to use the percentage sign. This is the modulo operator. If number is divisible by 2, so modulo 2, what that means is, if for instance number is 4, if we divide 4 by 2, then we get 2. The remainder is 0, which means this number, it is indeed divisible by 2. If we have a 5, for instance, 5 divided by 2, it's what? It's 2, and the remainder is 1 to get to 5. So this number, of course, 5, is not going to be divisible by 2, so that's how it works. All right, so if that's the case, then I'm going to just print, and put that inside of F string, and I'm going to put a new line just to organize a few things before we print that. And let's say the number, and I can say number is even. Okay, so if this is true, right, if the remainder is 0 when we divide by 2 that number, then we know that it is indeed an even number. Else, we know that the number is not even, so we can print. Again, I'm going to add a new line and say the number, and I can pass the number that I have entered. Make this an F string, of course, is odd. Okay, so let's go ahead and see if this works. I'm going to run real quick. Okay, so enter number, and I will tell you if it's even or odd. And I made a mistake here. This should be even. Okay, let's Control C to exit, and we run this. All right, let's say 5. Okay, the number 5 is even. Okay, something is not right. This should be. So we have an issue here is because I actually did not finalize or finish my if statement here. So what I want to say is equal to 0. Yes, because we want the remainder to be 0, as I was explaining to make sure that this actually works. So that was my mistake. It happens. Okay, let's go ahead and run again. And if we put 5 again, this should say number 5 is odd. All right. If I go ahead and run once again, I put 4, it should say 4 is even, because it is indeed true. So you can put any number that you want. Let's go back and put something like this and hit enter. Well, seems to be even. Very cool. All right, so that works. And you can see now part of the power of having users being able to enter something in our prompt, so we can take those inputs and do something useful. So what I want you to think about now is perhaps maybe a little game or something else that you can create, allowing users to input information, and then we'll grab that information and we can then do some computation and get to a certain result. Go ahead and do something similar, and I'll see you next. So we've learned about for loops, and they're wonderful because they give this automation where we want to repeat certain tasks, which is wonderful. Now we're going to look at the while loop. So while loop is different from for loop in that the while loop runs as long as or while a certain condition is true. So we can say while variable x is less than 5, this should run until that condition is met. Then we break out of that while loop. Okay, so here is a simple while loop. So you can say while, that's the keyword you use. I can say while counter is less than 5. Then I need to do something. In this case, I'm going to go print, say counter is, and I'm going to pass the counter. Now, of course, the counter hasn't been created, so we need to instantiate or say counter here, declare. This is our while, so we say while counter is less than 5. Then we're going to go and print the counter is like that and pass the counter. Let's go ahead and save this and see how this will work, and continues going. Wow, that's not helpful. So this will continue forever. So this is part of what we talk about infinite loop. So we don't want that. So I'm going to go say Control C to get out of that. So you can see here, it kept going. You can see to the right here, I have this bar that I can go all the way to where it started. So it will continue going until the end of time. So we don't want that. So what that means is that with the while loop here, we need to also have a counter that is counting as it goes. So the idea here is that we're going to say counter, and we're going to say plus equal 1. So what's happening here is we can say as we go through, we're going to increment the counter. Now, it's a very strange syntax if you are not used to it. So we say plus equal 1. So each time we're going to increment the counter as we go through, right? So this is what you need to do with a while loop. Otherwise, it's going to keep going forever or until you lose all of your memory. Okay, let's go ahead and clear all of this and run again. And you can see now it worked. So it went ahead, counter 0, 1, all the way to 4. It makes sense. So the first is 0, less than 5. That's true. This is going to run. And then we increment. And then now is 1. It's still less. Run. And then we increment and so forth. So that is indeed a while loop. Now this here, just to give you an overview, we could have done is the same as saying counter is equal to counter plus 1 like this. It's just that the other way is just a succinct and to the point way of declaring it. All right, so I'm going to go back to what we had. The weird thing about learning about the while loop is that we can make our programs even better. So we know loops, we know while loops now, so we also know how to get input from the user. Let's do a simple game here. We can allow users to enter something to quit the program. So let me go ahead and comment this out. Say, create a prompt variable here. Let's just start with a new line. Say enter, quit to end the program. Now, there's one thing I want to show you here. You see that whenever we want to show something in parentheses, because we're using double quotes here, we actually put single quotes around the word that we want to show in parentheses. Okay, that's very important. So if we had been using single quotes, then we'll have to use double quotes. So it's going to be the opposite of what we have enclosed everything in. Say prompt, and just like we did here, I'm going to actually add something to that prompt. So I'm going to say plus equal. We can add another string or text. So n, and say enter your command as such. So let's go ahead and I'm going to just go ahead and print prompt so you can see what's going to show. So as you can see, right, enter quit to end the program and then enter your command as such. So this is what's happening here, is that we're just saying we're going to add to the first prompt another text. I'm going to get rid of that. So what do we want to happen now? Well, we have the prompt enter quit to end the program as well as the enter your command. So we're going to use the while loop, right? So I'm going to say while. Now, while is true, because remember, whenever we're using whiles or the loops we have learned, it's all about looking at this expression here, which should return true or false. So we can say while true, makes sense. We're going to say command, create a new variable here, and we're going to just get the user's input, which is going to, then I'm going to pass the prompt like this. So it's going to pass this prompt that says enter quit to end the program, enter your command, and so forth. So while that's true, right? So which means the moment we start program, it's going to be true. This is going to happen. So now we have whatever they've entered because we have the input here, and then we can check, right? So I can say if command, whatever we're receiving, right? Because this is going to be a string, double equals to check for equality. If it's quit, right? Then what we want to do, I'm going to just use the break keyword. So this means go ahead and exit this loop. That's all it means. So just break out of it, exit out of it. Then I'm going to say else. Then I'm going to just go ahead and print f string here and say you entered, and then I'm going to put the command they have entered. Let's go ahead and save this. Okay, there we go. Enter quit to end the program. I'm not going to enter quit. Let's just enter 7. You can see that it will continue, right? Because 7 is not quit, which means then we need to continue the program, because that means this is still true. So we're going to go back to ask for that command, right? The prompt. So I can say hello world, hit enter, enter quit to end the command. If I don't enter anything that resembles quit, it will continue going because this is still true. But if I go and say quit, and you can see that now the program ended, right? We exited that loop. Very nice. So now we're starting to see very exciting programs, things that we can actually start doing to interact with users and do things. That's very basics, but at least you can see what else can be done with inputs, the while, loops as well, just loops in general. So let's do a quiz game here. So we're going to present the user with a series of questions one at a time, and the user will be able to accept answers from the user, and then the program is going to be able to accept answers from the user and check if they're correct. Now we're going to also be able to keep the score of how many questions the user has answered correctly. This program is going to continue until a question or all questions are answered or the user chooses to quit. And then we're going to display the final score at the end of the game. Okay, so I have a list. Actually, this is indeed, this is not a list. This is a dictionary of questions. So you can see we have question, right, as key, and then the value as the answer. So what is the capital of France? Paris. What is 2 + 2? 4, and so forth, right? So we just have 3 questions here, but we can add as many as we want. All right, so let's go ahead and start putting together the logic. So first, I'm going to create a few variables. So score starts at 0, and then I'm going to get the total number of questions that we have here. And how do we do that? To get the total number of questions that a dictionary has, we're going to use the len function. So I'm going to say len, and then I'm going to pass the questions as such, and I'm going to put that inside of a variable called this total questions as such. All right, so now we have all the questions, total questions number here, because we pass the questions through a len function, which returns, in this case, an integer which will have the length of our dictionary. Okay, so first we're going to go ahead and print something here. Say print, just a nice welcome to the quiz game. Okay, and then I'm also going to print another print here that says some instructions. So type quit at any time to exit, and then let's put a new line there so that way we can start the game. All right, because we're going to iterate through the questions, and as we iterate through, then we have other logic. Okay, so let's go ahead and do that. So I'm going to say for question, because we need to get a question, and I want to also get the correct answer. This is the beauty here. We can put into these variables because we know we have the question and then we have the answer. So we're going to loop through all of that and retrieve all of that information. Okay, we're going to retrieve that from where? Questions, right? Dot items as such, and then here is where we are going to add the user answer. So I'm going to say user answer. I'm going to put that into an input. So I'm going to say input, right? Because we retrieving the user answer. I'm going to say question, and I'm going to do an append, just an empty string like this. What will happen here is that we're going to have the question, and then we're going to append just an empty string as such, and that's going to be our user. Let's go ahead and actually print so we can see. I'm going to say print our user answer as such so that we see. I'm going to save and let's run. Okay, so welcome to quiz game. Type quit at any time to exit. What is the capital of France? So I'm going to say Paris, enter, and you can see it goes straight to what is 2 plus 2. So this is exactly what we want. Now let's go and continue with the logic. So now that we have the answer, what we want to do is we want to check it. So we want to check, for instance, if whatever they have entered is quit to start with. So I'm going to say if user answer, I'm going to actually use the lower function here to make sure that is lowercase, is equal to quit, right? I want it to be lowercase quit. If that's the case, we're just going to go ahead and break to exit this loop. Else if, so elif, if user answer that lower, just to put it on lowercase, is equal to correct answer, I'm going to also call the lowercase just to make sure everything is lowercase. If that's true, we're going to just print right away here something that says correct. And once that happens, we know that the user is correct. So we are going to say score, and we're going to increment our score by 1. Else, in another case, what we want to do is we're going to print something that says, put an F string here, wrong, the correct, and then we're going to pass the correct answer is, I'm going to pass the correct answer as such, because the correct answer, we know the correct answer for each answer because we're inside of a loop. So we know the question and the correct answer. So we can pull in the correct answer to say that is the correct answer. The next thing we'll do is I'm going to get out of that else, or I'm actually out of this if statement here. Indentation is very important. And I'm just going to go ahead and print here. So you can just print something, which means we're not going to print anything, but that just gives us a little space in between. Okay. And then outside, make sure again, we are outside of for loop. This is very, very important. So I'm going to indent all the way. So outside, same line as the for, I'm going to then print the results. I'm going to say print. I have a string here. I'm going to say quiz completed. Your score is, and then because I have the score been counting on here, passing the score, divide that score or add the / like this, total questions like this. So it's going to be your score is 4 out of total questions, something like that. All right, let's go ahead and save this and see. Okay, so welcome to the game. Let's make this larger. What is the capital of France? I'm going to say Maputo. I know it's wrong. Wrong. The correct answer is Paris. Okay, what is 2 plus 2? I'm going to say 5, which is wrong. The correct answer is 4. Who wrote To Kill a Mockingbird? I'm going to say Harper Lee as such. Hit enter. Voila. That was the correct answer. And you can see I only got 1 out of 3. Very good. And once we get to that point, of course, it exits out and all is good. Let's go ahead and run again. Just don't want to see what would happen. So I'm going to say France, Paris. This is going to be 4 and say Harper Lee. All right. So I got 3 out of 3. Very good. So it is indeed working. Now let's go ahead and run again one more time. And I say quit. Voila. You can see it quit, and then it says quiz completed. Your score is 0 out of 3. Because I said quit, it went ahead and looked at the answer. It's quit. It just breaks out of this whole program. Now with while loops, you can do all sort of things, because remember, we're checking to see if the condition is true, and then we'll continue doing whatever needs to be done until that condition is not true anymore. So it's very powerful. Now imagine that we have this ingredients list here with a bunch of ingredients. Make this smaller so perhaps you can see everything. So you can see ingredients, we have all these ingredients here. Now imagine that we want to write a program that will remove certain ingredients that are repeating themselves. How would we do that? Well, we can use a while loop, right? So in this case, I can say while avocado, because I know it's repeating, in ingredients. And then I can just, because it's a list, can go ahead, say ingredients, that remove, and pass avocado. And then in the end, outside of our while loop, I can go ahead and just say print ingredients like this. So before, I'm going to print the ingredients so we can see the difference. And let's go ahead and run. Okay, so before we have avocado, tomato, avocado, repetition, and so forth. And now we only have 3 ingredients because we have removed, indeed, the avocado. Let's go ahead and do a fun program here that will ask users to list countries they dream of visiting. And then we're going to store those countries in a dictionary where each country can also have an optional note, like a specific place they want to see or any activity they want to do there. Now, if the user doesn't want to add a note, they can just press enter and only the country will be stored. And at the end, we'll display the list of all dream destinations they have added, and it's going to be fun. Let's go ahead and do this. First, let's go initialize an empty dictionary. So we'll call dream destinations. And I'm going to go ahead and print a few things here. So say, let's plan your dream travel itinerary. And we can even put a little plane there as well because it's just fun like that. And then let's go ahead and print enter done when you're done or when you're finished. Then let's just give a new line like that. Okay, let's make this a little bit smaller so you can see what's going on. Now we're going to use a while loop. So I'm going to put a while. So while true, okay, start an infinite loop to continuously ask for user input, right? And then I'm going to use input and say, which country would you like to visit? And I'm going to put that inside of a variable called country like this. Okay. Now I'm going to check if country, and I'm going to say lowercase, is equal to done. Just put double quotes like that. And we're going to go ahead and break. Okay. We've seen this before. So just get out of here. And then we're going to also pass another input here. So I'm going to say input. I want to allow users to add a note. So I'm going to put inside of f string anything specific you'd like to do or see in, and I'm going to pass the country that they have just entered. And then I'm going to tell them that if there's nothing, just say press enter to skip. All right, pretty long, but that's okay. And I want to put that, of course, inside of a variable called this note. All right, so once we have that, now we're going to go ahead and add the country and optional note to the dictionary. How do we do that? Well, we have our dictionary, which is dream destinations here. We've seen that. We created that earlier. And so I'm going to use it. So dream destinations. And now I'm going to add a key, which is going to be a country. So I'm creating this dictionary, which will have key value pairs. So country, and of course the note if there is a note. So we're going to have the country, but also I want to be able to optionally add the note. Now here's the cool thing that we can do with a ternary operator, which means I can say something like this. Look at this. I can say note, if note, else. I want to just say no specific plans, something like that. This is beautiful. So here what we're saying here, we're saying, okay, if note, there's something, we have a note, in this case something was entered, then we're going to pass that into note. So that means now we have country, and of course the key is going to be the note for that country. Else we're going to say no specific plans. Very cool. So in one line we're able to add that if statement there. And then after that we're just going to go ahead and print. I'm going to say got it, and then say let's keep going, or type done to finish, like that, to give users something to do. Now remember, all of this is inside this while loop, and then what I will do here is I'm going to get out of this while loop because I'm done at this point. I'm going to go ahead and print a message. So this message, I'm going to just start with a new line. So this message is going to say your dream travel itinerary, and I'm going to print it. So to print all of our itinerary, that means I have to loop through our dreams destination, which at this point should have country and notes if there are notes and so forth. And so what we'll do here, I'm going to say for, I need to get the country as well as note, because there might be a note in dream destination dot items, right? And then what I want to do is I'm going to print an F string here that will say, I'm going to put a dash and I'm going to pass the country, and then I'm going to pass the note, just like that. So it's going to say Mozambique, for instance, and then note whatever I specify for note. All right, so I'm going to get out of that loop because I don't want to continue. And then at the end, just to make it even more beautiful, I'm going to say print, add a new line there, say looks like an exciting adventure awaits. Safe travels, like that. All right, so we did a lot of things here, but you see, this is a cool, fun application. So we're going to learn a few things here. We've learned a few things. We've learned how to add, in this case, filling a dictionary with user input. Let's go ahead and run this because I'm actually excited. Let's go ahead and say Python. Voila. So let's plan your dream travel itinerary. Enter done when you're finished. Which country would you like to visit? I'm going to say Spain because actually I would like to visit Spain. Anything specific you would like to do or see in Spain? Oh, I love flamenco music. So I'll just say flamenco and guitars. Got it. Let's keep going or type done to finish. What other country? I'm going to say Moldova. And I'm going to just go ahead and press enter to skip. Got it. Let's keep going or type done to finish. I can continue. Let's say, what are the countries? I want to go see all the countries in the world, really. Let's see. What else? Finland. I'm going to say everything for notes. Okay, let's continue. Which country would you like to visit? I'm going to say Chile. Oh, music and food. Okay, which country would you like to visit? Know that I can still type done if I'm done, right? I'm going to continue here. I'm going to Panama. I'm going to skip. And now I'm going to go ahead and say done. Voila. Look at this. Once I'm done, it says your dream travel itinerary, Spain, flamenco and guitars, those are notes, and we have Moldova, no specific plans, Finland, everything, Chile, music, Panama, no specific plans. And voila, looks like an exciting adventure awaits, safe travels. Beautiful. So cool. All right. Just like that, we're able to create something that is pretty useful. Hopefully, you can start thinking of things that you can do with what you just learned here. Very simple application, but it's pretty fun. So we're able to fill in a dictionary with user input. So now we are taking all of those knowledge, all of these things that we've learned and put into practice to something useful. I hope you start thinking of things you can do here. What about taking all of these items that we have here and save them in a text file? Ah, right. So in fact, I know this is still the beginning of our journey, but how about you trying to figure out how to do that, right? We have the information was entered. How about trying to save it into a file, a text file or so? Okay, that's a little challenge. Go ahead and do that. And also make sure to think of other projects, little programs that you can create using the same logic that we wrote here. Oh, this is so exciting. This is just the beginning. So now we're going to talk about functions, and we've seen parts of functions and I've name dropped as we were doing all of the basics of Python up till now. So you've heard or you've seen functions before, but now we're going to go deeper and look at them because they are a very important building block of any programming language, specifically in this case, Python. So functions in Python are a fundamental concept used to encapsulate code blocks for tasks that you want to repeat throughout your program. Functions are great because they allow you to organize your code into smaller, manageable pieces, which improves code readability and facilitates code reuse. So I want you to think of a function as a recipe, right? It takes some ingredients, in this case inputs, and then follows a set of instructions, that's the code block, and then produces a dish, which is in this case the output. All right, enough talking. Let's go ahead and take a look. How do we declare a function? All right, so to declare a function, we use the keyword def like this, which is definition. So to define something, a function in this case, and you call the name, for instance, greet. And then to make sure that this is known as a function, we have to add those parentheses as such. Okay, and then we have colon to say now, hit enter, we can start the code block. So whatever we write here is going to be part of this function, right? So now I can say print hello Paulo, for instance. Okay, very good. So there is the function there. Let's go ahead and run and see what will happen. So if we go ahead and run, you can see that nothing happened. Well, the reason being is because whenever we declare a function as such, we need to call it. Call it is essentially the same as running that function, to say that we want to run that function, right? So to call a function, it's very simple. We just call by its name, such as greet, like that. And make sure that you put parentheses like this. Now, if we save this and do the same thing and run, we can see hello Paulo. So this is a very powerful concept in programming in general, because now we can see we have declared this function which does something specifically. Now this is very simple, of course, but you will see that we can do all other sort of things that are a little bit more complex, and we have all of that inside, encapsulated into a code block that we can call repeatedly. So I can go ahead and call again as many times as I want, and you see that I can have hello Paulo, hello Paulo. One of the things I can do, I can actually create a while loop to call that same function. So I'm going to say, for instance, counter 0, and then I'm going to use the while counter is less than 10, and I'm going to call greet. And of course, let's make sure that we say counter equals or plus equals 1 to increment that counter. Okay, so now it's going to go through. While counter is less than 10, we're going to call the greet function as many times as necessary. So let's go ahead and run, and you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Very good. So there we go, the power of functions. Now, of course, you've seen functions before, and I've talked about functions in passing. For instance, actually, print is indeed a function, right? This guy here is a function. If you hover over, it says function in parentheses, and that's how it's defined in Python, right? So there we go. So you've been using functions all along. You perhaps did not know. So that is the beauty of functions, is that it's a block of code that you can call that block of code whenever you want to call it. And that block of code does one thing specifically. And there you have it, functions. And so now we know about functions, and we say that functions allows us to pass, for instance, ingredients. In this case, will be data. And with that is passed in a function called cook, and then we get the ingredients, we have to make a dish, all these different instructions, and then later we'll return that dish. So essentially we call cook and we pass those ingredients, and then of course you end up getting a dish. So that is essentially what a function does. But this function here assumes that we're passing the actual data. The function we just created doesn't pass anything. Let's go ahead and make it so that it actually passes something. So back to our function here, what we do here is we set parameters in a function, right? So parameter is anything that we pass that we want then to pull in inside of that function. We do something and return something. Okay, so in this case here, I'm going to pass in a name. So now think of this as just a variable, but it is called a parameter. Now in certain languages they call this argument, parameters, and so forth. Essentially we're saying the same thing. So it's just the data that we pass through that function, where then inside of the function we're able to pull that data and then do something with it. So in this case here, since we pass name to this function, that is the parameter. Now, if you hover over, you can see that the function, when we call it, says def greet, and there is a name which has any type. We'll talk about types later. Okay, so now it's expecting in a way to pass something. If we were to run this, let's go ahead and run this again as is. You can see that we're going to have a problem. It says missing one required positional argument, name, which essentially says that we need to pass something, right, when we call it. So I'm going to pass here a string called Paulo. So now that I have this name, I want whenever we print something to show whatever we passed. So in this case here, I'm going to put an F string, so like that, and then pass our parameter name. Now this becomes a little bit more flexible. If I run this, you can see the same thing, hello Paulo, and so forth. But the beauty here is that it's not hard-coded because we just pulling in the parameter that was passed in and display that, which means whenever we call, we can change this. For instance, I can append in the greeting here, so I'm going to put F string again, and append our counter just to see. Say Paulo is number, something like that. Let's see what's going to happen. Let's run once again. You can see now, hello Paulo is number 0 all the way to 9. But the great thing is I can change the name here whenever we're passing it. I can say, for instance, Alice, and go like that. You can see now, hello Alice is number and all that. So we can do all sort of things, all things that we may want to do, because now we're passing an argument, a parameter that is, and then when we call it, we are passing that argument. In this case, we're just adding Alice, the name, and then we're appending other things as well. So that is the beauty of passing parameters. Now, the thing here, I can pass more than one. So I can put comma and say age, for instance. Now, if I hover over where I call, you can see that it says name and age, which means that is the expectation. So now I can say hello name, and then I can say your, and then pass the age, years old, as such. Okay, so now I can just get rid of all of this. I can just pass, for instance, Alice again, and then comma. I can pass, say, 45. So let's go ahead and run. Okay, hello Alice, you are 45 years old. Hello Alice, you are 45 years old, and so forth. Okay, very good. So there we go. You are now able to pass parameters, and then when you call that function, we call it passing then arguments. So when you're defining a function, they say these are supposed to be called parameters, and when we call the function and pass whatever we pass, then they are arguments. But really doesn't matter. At the end of the day, they're just parameters, arguments. But anyway, there you have it. So far we've just been able to print something from our function, and that is not all, which means a function can also return something, right? Meaning we pass in the information, the data, and so forth, and then we do some calculations, computation, whatever we want to do, and then return that result so that we can capture it and do other things later. So let me get rid of this real quick. I'm going to define a new function here, format name as such, and then this function will take first name and then last name. Right? So what we'll do here is we're going to take these parameters, will be passed in as arguments, and we're going to format into something that is better. Okay, so I can say here return, that is the keyword, which means we're going to return something. What we want to return is something that says full name, and I'm going to invoke the title function to make it look better. We've seen this before, right? So I'm going to create the full name variable here, which will get the first name and last name and format it so it looks nice. So full name, I'm going to set that to an actual F string, and then I'm going to say first name and then space last name. So there we go. So you can see we're not printing anything. So now we can call this format name and pass the arguments and put everything in a variable. So I can call it, if I say format name as such, and then I'm going to pass, I'm going to use the keywords. I'm going to use keyword arguments, but we could just pass the strings, like first name, James, last name, Bond. Okay, so now we call that. So what I want to do, I want to put that into a variable. I'm going to call this formatted name, which means I can take that and print, right? So print formatted name as such. So you see, we are returning something useful, something that we want to make sure it looks nice by passing in the first and last name, and we do some sort of computation, right? Formatting things in this case, and then we'll return that, right? And then we can call that function and put that, because we're returning something, this is key, we can then put all the information that we are returning from the function into a variable. And the great thing here, if you hover over, you can see the structure of the function now. It's a function, we're defining it, we're passing in some parameters, and you see this dash greater than, so it's an arrow that says string, which means we are returning a string type. So it infers from what we are doing inside of this function and what's been returned, it knows that this is going to be a string, because indeed all of this is going to be a string. Okay, that's very beautiful. So now let's go ahead and then run this, and you should see James Bond, because all we did really is just we took the first and last name, in this case, and we said full name, that title, which, as you hover over, returns a version of the string where each word is title cased. So it looks really nice right now, even though when we passed those names, in fact, I can go ahead and say J and then lowercase b. That makes more sense. Let's run. Of course, we're going to see that they are now title cased like that. Right? So this is a nice example. Now, what I want you to do is to think of another example. We are, in this case, passing just strings. We could pass integers, numbers, and so forth, and try to find something or create a function that returns, in this case, an integer or a calculation of something. Try to do that, and I'll see you next. So now we're going to talk about a very important concept in programming called OOP, or Object-Oriented Programming. What does that all mean? Well, it all starts with this concept of classes. So in programming paradigm, where we use objects to represent data, so the idea here is that we want to use objects to represent data and methods to operate on that data. So let's, first of all, at the center of everything, we have what we call a class. So a class, as you will see, is essentially a blueprint for creating objects. So it is a blueprint of what we can use to instantiate and create an object which we can use. So we are mimicking a real world scenario in code, and that is very powerful, as you will see. So essentially what we have here is as follows. Let's give an example so you can hopefully have an overview of objects and classes and how all that works in a real world example. Let's imagine that we want to build a Python application that allows users to save books. Right? Now we're going to abstract out all of other things. We just focus on a small part of this whole project here. You can see that I have books here in bold. The reason being is because the book, in this case, is the central piece of data that we need. So a book in the real world is an object. So how do we represent that object, which is a book? In this case, a blueprint. Well, in code, we represent that by creating a class, which again is a blueprint of a book object. So it's not the object, it's a blueprint that can be used to generate that book object. So essentially, a book has a few things. A book has a title, an author, a genre of that book, and of course, these are called the attributes. So these are the attributes that are part of what a book is in reality. Okay, and then we will have read book, for instance. That would be a method, right? So that is a method or an action that happens. So the idea here is that we want to take this class, it's a blueprint, and instantiate, in this case, that class into an actual object. So essentially, we can say book, and we can pass the kite runner as the title, and the author, Khalid Hosseini, and fiction as the genre. Okay, so now a book is indeed an object because it has a state, it has a title, it has an author, it has a genre, and so forth. So that is essentially an overview what object-oriented programming really is. So again, this paradigm of OOP, object-oriented programming, is one of the most effective approaches to essentially writing software. Because in object-oriented programming, you write classes, the blueprints, that represent real-world things and situations, and you create objects based on those classes. So when you write a class, you define the general behavior that a whole category of objects can have. And that's very powerful because now you can do all sorts of things. You can essentially avoid repetition when you create those objects in your program and have a paradigm that you can follow that specifies certain classes, certain objects, which you can instantiate those classes into objects and do all sorts of things. So it's a beautiful thing, as you will see in a second here. So let's go ahead and see how we can get started creating a class and later instantiating that class into an actual object. Okay, so we are going to go ahead and create a class. To create a class in Python is very simple. We use the keyword class as such, and then we pass the name of the class. So let's continue with the example we started with, which is book. Now, the naming convention is very important. You notice that here we have uppercase first letter. So that's what you need to always think about. Whenever you create a class is essentially a noun, right? A house, car, movie, and so forth, a book, right? And so you want to start with an uppercase letter as such. And usually it should be, like I said, a noun, which usually has to be just one word, but there's some exceptions there. All right, so there we go. We have class book and then colon, and there we go. Now inside here, we're going to have the creation of the actual class, right? So we're going to put all these pieces, the attributes and so forth, that will allow us to instantiate this class to create an object. But before we do anything, what I want to do also, I'm going to add here and generate a doc string. And I'm going to just go ahead and say a class to model a book. Okay. In this case here, we can go ahead and set up the attributes, right? The attributes of a book. So we said, for instance, we have title, and I'm going to set it to an empty string. And then we have author, also to an empty string for now. And let's say genre, an empty string for now. So now that we have this class, let's go ahead and see how can we instantiate this class to make it an actual object. So outside, I'm going to create a variable called book. Go ahead and say is equal to book as such. The moment you do that, you have over. You can see it says this is indeed a class to model a book. This was my mistake, not a bool, a book, like that. So it tells us that it is indeed a class that we're instantiating here. But now this is not just a class. That means where we have a book here, if you have it over, it says a variable. But you notice something different. It says variable, says book, colon, a book. So it's saying it is a book type, which means is a book instantiated. It's a book object. And the beauty here is that with that object now, I can do all sorts of things. In this case here, I can go ahead and set things up. Actually, what I'm going to do for the title, I'm going to just add book title like this, and genre, let's say author, let's say Paulo, and genre, let's say fiction, just to get started. So now I have my object. This is how I instantiate a book. I have an actual object that I can do something with. I can go ahead and print. I'm going to say book, and I can access certain attributes. If I say dot, you can see that I have access to author, genre, and title, and a few other things here that we are not interested in looking into now. So if I access the attribute actor, or author, I should say, like that, let's see what's going to happen. I'm going to go ahead and run this. Voila, you can see, there you go, we have Paulo. If I want to access genre, I can dot genre, and we are going to see that we have fiction as the genre. And just like that, we have a very specific book that we created, in this case, right, object, which we can then go and get information about it. So this is indeed a class, and here we instantiate it to create the actual object which we can work with. Now, the beauty here is that we can also go ahead and define functions. But the thing here is that functions are called functions outside of a class. So inside of a class, these are called methods. So I'm going to define a method here real quick. So I'm going to say def, just like we've defined a function before, but here are called methods, and call describe a book, and print describing the book. ... Okay, let's go ahead and save that. And because we have that object we created here, we can access the attributes. We can also access that method. Say dot, you can see now we have this describe book, which is indeed a method, right? And because we use a method or function, but they're called method because they're attached to classes, of course, we have to put parentheses to say, now we're going to call it. So if I save this and run, we can see it says book.author. Oh, I did something wrong. I don't want author, I want describe. There we go, describe book. My bad. Let's go ahead and clear and run this one more time. And you can see it says book.describe book takes 0 positional argument, but 1 was given. So what's going on here? Well, there are a few things which we're going to get into. The idea is that because this is part of a class, we need to pass something else for all of the functions or methods in the case that are created, defined inside here. So this thing is called the self. The self, if you have over, is indeed self at book. What does that mean? Well, that means that self is essentially this book, right? It's referencing our class book here. So we need to pass essentially to say that this belongs to this class, kind of, all right? So that's the reason why if we don't put that and try to run, we're going to get that error. So I'm going to go ahead and save this real quick. And now if I go ahead and run, you can see that, voila, you can see describing the book. Very good. So this was a very simple introduction to creating classes and instantiating them. Now we're going to make this better so that we can really have a solid class, therefore being able to instantiate solid objects from this class. Now the way that we described this class here, it's okay, because actually what is happening here, we are hard coding, which in this case works fine, but that's not what we want. When we instantiate or create an object, or rather when we create a class, we want to make sure that the class in itself, when we instantiate it, it has to have a state that is ready, which means the object has to be ready to be used. At this point here, if we didn't have added anything like that, right, in this case here, so every time we instantiate this book, we're going to get the same thing for our title, author, and genre. And this is not good. That's not what we want to do. So what we want to do here is, in Python, we have this function that allows us to initialize this object. So when the moment this is first run, it's going to call this function and initialize the class, in this case, the object. So we're going to say shift underscore twice, and then say init, right, trailing, oh, actually leading, and then trailing also like that. Okay, so what we'll do is I'm going to go back and say def, because this is going to be actually a function. So it has to be exactly like that. Okay, 2 underscores, trailing, and then 2 underscores after init. And then we're going to pass something. So we're going to pass self to represent this class self here where we are. And then we're going to pass, in this case, some of the attributes. So I'm going to say title, author, and genre like this. So what that means now is that we can set our object to be ready to be used the moment that this is run. So this is very important, by the way. This is specific to Python. This just tells us that it's going to initialize. This is the function that will be run the first thing when we instantiate this object. And I can show you exactly by printing running init like that. Let's go ahead and save. And now I'm going to leave everything as is. And what I can also do here, I'm going to put, instead of description, I'm going to say running describe book, something like this. So we can see what will happen. So let's go ahead and run this. You can see that it says book. We have an issue here because the init is missing 3 required positional. That's my bad. I'm going to go ahead and just remove all of that for now. And let's go ahead and run again. And you can see running init, and then we are going to run describe. So init is the first thing that's going to be run when we instantiate our object. All right, let's go back, put all of those back. All right, so now that we know that this is what's happening, inside here, this is where we're going to initialize or set up, indeed, our title, author, and genre. And the way to do that, we say self, we're going to have to go through self to get to our title, author, and genre. And these are actually, could be outside here as well, but we can pass them as such to say these are indeed our attributes. So I'm going to self dot, you can see I can go and say title. I'm going to set that to the title that is going to be passed on. So remember, this is going to be what's going to be called when we say book like that. And you can see the moment I hover over the instantiation of this object, now you can see it says book, and then we have title, author, and genre. Interesting, right? So that means indeed, whenever we instantiate it, that is what it's going to be called. This is what sets up the entire object. Okay, so we're setting the title of this attribute of this class to the title that we're going to be passed. Okay, and then I'm going to self again, author. I'm going to set to author, and then self genre, set that to genre as such. Now, if we try to run this, we're going to have some issues, right? I'm going to run this. You can see that it's going to say type error book init, missing 3 required positional arguments, which are title, author, and genre. Makes sense because we want to have an object that is ready to go, right? That is initialized. So that means I need to pass something here. So for book, say the Hitchhiker's Guide to the Galaxy. Okay, and then just put a new line. I'm going to add the author. Let's say Douglas Adams. And then the last one, which is genre. I'm just going to say, I think it's fiction. I'm not sure. All right. So now we have indeed instantiated an object. So we have an object that is ready to go because we have to pass, we're forced to pass something, these arguments, through our init function or method in this case. So now if I run this, in fact, I can go ahead and say, just remove that, just go ahead and print the book object itself. Let's see what's going to happen. We can see it says main.book object and so forth. What's going on here? Well, what's happening here is as follows. We have the actual object, right? And it says at this. So this is where this object is in memory because at this point, we just have an object that we're not doing anything with it. We're not accessing anything to it. So the object is there. It's not until that we say dot and get genre or title that we are going to be able to get something from that object. So I'm going to go like this and run again. And you can see the Hitchhiker's Guide to the Galaxy. Now, the other cool thing that I can do here, because anytime that we call just the object that was instantiated, you saw that we get this gibberish that says essentially just an object. It's a representation of that object in memory, but we want to make sure that this book, when it's called like this, that we show something to show what this object contains. That's when we can also pass another definition here, say def and underscore underscore and say str and then underscore underscore like that and pass self, right? So this one here, what will happen now is that we're saying we want to show the string representation of this book object if we just were to call it like this. And here I'm just going to go ahead and print something like, say, put an F string. I can say book object, and I can pass, for instance, self.title and self, let's say title, and then let's say author, self.author as such. Let's see what happens now. So I'm going to save this and I'm going to leave as is and I'm going to run. Notice earlier, this is all we got, but what's going to happen now? If I go and run, looks like string return non-string type non-type, because here I actually have to return that. My bad. All right, so let's go ahead and save and run this again. And voila, you can see now it says book object. It gives the title, Should probably make this a little bit better, but it's okay. So it gives it a title, and the author is Douglas Adams as such. And there we go. So this is another great thing about classes in Python, is that we can also have this underscore str underscore double underscore, and then we can return the object representation, in this case, something that we can actually see instead of just that gibberish of the actual object in memory, which is not very helpful for us or for anybody else, right? And there we go. So we are making progress here. We'll be able to now define the init function, method, I should say, which is called right when we instantiate that object and call, right? First thing that's called. So we need to pass those attributes just like this, as you see, just like parameters, really. And then we also added this string method, which allows us to return the visual string representation of our object. So that way, when we just call the object like this, it's going to give us some information about the object. We could have added, of course, title, author, we did. We could add also genre and all sort of things, but this is better than what we saw before. Just like that, we're able to have a pretty secure and well done, well put together class, which then we're able to instantiate as an object. Okay, so we can continue in adding more methods here. So the other methods, or another method I'm going to add is so first for describe book, let's go ahead and make this a little bit better because that's just not very helpful. So let's say f string here, and I'm going to say self, get the title of the book, say by self.author, and then genre, and pass in the self.genre as such. All right. Very good. And let's add another method here, which is read book. So I'm going to pass self, and then go print, and f string, say reading self.title by, then pass self.author as such. Okay. All right, so now when we say book.read book as such, should get me something, and so I'm going to print again book describe book like this. So let's go ahead and run. Should get something better. So okay, says here reading the Hitchhiker's Guide to Galaxy by Douglas Adams, and then Hitchhiker's Guide to the Galaxy by Douglas Adams, and genre is fiction. Okay, all right, so this usually happens. Just remove those parentheses there. They usually added automatically, so that's not needed. That's why we're seeing Douglas Adams inside of parentheses like that. All right, let's go ahead and rerun this real quick. And you can see all is clean and it's looking good. So with our class here, we can also add default values for certain attributes. For instance, I can say that I want to have this self.num pages and give it to 230 as the number of pages for this book. So then I can create a function here that essentially retrieves that information. Right? Say define get num pages, pass self. Let's go ahead and just print. So this book, I can say the self.book has self.num. Let's see, this has to be f string, so num pages. That's that. And now if I go to go ahead and say book, get num pages as such, and see what will happen. Self.book, that was my bad. This has to be self.title. All right. Okay. The Hitchhiker's Guide to the Galaxy has 230 pages. The other thing we can do, of course, these classes need to be immutable, which means we can change, modify things, and update things. Now, we can modify an attribute value by going straight to that attribute. So we have our book here. I can say, for instance, book pages and give it to some random number. And now, get num pages, you will see that instead of having the 230, we should have something different. Let's go ahead and check it out. And you can see that we have updated the num pages, right? Now, this is good and all, you can do that, but there's a better way to do so, or another way to do so. The other way is to create, or in this case, update the attribute value using a function, a method, I should say. So def, say update pages, page nums. I'm going to pass, say new pages. And now I'm going to do here, because it's self, that num pages, I'm going to set to new pages like this. Okay, if I want, I can just go ahead and print. I can say book or self. Let's see. Self.title, updated number of pages to, I'm going to pass the num self.num pages like that. I can call, instead of doing like that, I can go ahead and call, say book that update num pages, and for num pages or new pages we call it, I'm going to pass 12. So now when we call just as it is right now, we'll see that indeed we have the updated to 12 pages. So we have that. So we have that string there, number of pages to 12, and then of course the other string that is being passed to say the book has now 12 pages. All right, so these are different ways to do the same thing. I like this way of actually adding or updating anything through a method because it's easier and it's concise and it's in one place and it just works way better. All right, I hope you were able to go through all of these hours, about 3 hours of Python, and you should have a very solid foundation of Python, how to work with Python, how to program in Python. So that was indeed my goal, and I hope I was able to accomplish in this mini course. So if you're interested in the full course where you're going to have more things, not only the basics of Python, which you've learned here, but go into more details about Python, on how to use Python to create applications, web applications with Django, use Python to create visualizations with data, parsing data, and using Python and AI, OpenAI API to automate things, right? Create tools that automate things in your life. So the full course is about 13 hours plus, and I'll be adding more to that. So if you are interested, just click the link in the description below and go enroll. Thank you so much. I hope this course was valuable to you. And as always, I'll see you next time.